All right. Okay. All right. So I got some echo feedback. Okay. I just get this microphone working properly. All right. Hello, everybody. Welcome to the stream. And this is our a day with Revit. Uh, more or less not actually a project tutorial by any means, but we're just going to be chilling and we are going to be watching project workflow. As you can see right now on the screen, we have an architectural model. We're going to start from here, right? And we've gotten some deliverables that let's assume we have from the client. We had one of our colleagues from the office work up with this particular drawing, and we're just going to start with this here. We just got the Revit file, and I'm just going to show you the project organization. Here we go. All right. So I always love to organize my files in a way that I can easily trace them back. So, for instance, you're going to be working with this on the cloud. You want to make sure you set this up, share this with everybody that needs to have it, ahead of time. And I have the project folder here, but this is the rules project folder. It probably should have the name or the project number. And then inside the folder, I have a subfolder called it's architectural. And this is where I store the architectural file. Now, I am acting as the structural engineer in charge, project structural engineer. And over here, I have the architectural folder, which I created. Let's assume I'm also the project coordinator as well. So I'm coordinating between all the disciplines. I create this architectural model or architectural folder, subfolder. Inside this folder here, I now go ahead and place the architectural model. Now, what I love to do is that I like to make sure that the files are named consistently. So over here, this is just a Revit backup file. Just going to go ahead and delete this. And over here, I have the name of the file followed by a hyphen, and then I have ARC abbreviation for architectural followed by RVT 2025, meaning that this was saved in Revit 2025. It's very possible that you're working with other team members that might be using older, uh, later versions of Revit, but you want to make sure you indicate it right. As a structural engineer, you have to make sure that the model that you are working with, or rather the Revit version that you're working with, is most up to date compared to the architectural. That way, you can always open their files. Revit has this issue of backlog uh, that is a bit hard to work with. Okay. Okay, I'm just getting feedback from the chats. My audio is low. All right. So, hello everybody. Welcome to the chat. So, if you can hear me, just let me know. If you can hear me now, so I see Elias. Thanks for joining. No audio. Just want to confirm if the audio is better now. Listen. Oh, still no audio. Still no audio. All right. Let's see if we can fix this. Okay. All right. Let's see. How about now? Is the audio better? Just want to confirm. Want to confirm with the chats. Okay, great. Great. I really want to make sure that this is done because we might be having a stream for over an hour. Let's just get to hear from everybody else. If you can hear me, let me know. Feels like a video conference again. All right. So I know I have some background music playing. Hope that's not shadowing the audio. All right, so we have the chat. We have a lively chat. All right, now so we see people joining from different parts of the world. I am currently streaming from Nigeria right now. So let's know where you're coming in. I have my second screen so I can see you guys' comments all the ways. So let's know where you're joining from. If you're joining from Nigeria, you can drop the Nigeria flag. I don't know if Riverside actually supports it. You can put your flag. Let's know where you're joining from. All right, so jumping back into the project. Okay, so I'm going to kind of start again because I'm assuming the audio wasn't that good. So over here I have the folder where I have the project stored, or the file stored, or the related file stored. So this is the name of the folder. Let me just assume that I placed it inside my download folder. I myself being more organized, I'll place it inside our roots database folder or the cloud storage, and share it with everybody that needs to work with it. So over here, I have the architectural folder. So these are where I'm going to store all the architectural references, and this is where I will expect the architect's Autodesk Revit project. And I always love to rename it in a way that I can easily identify it. So the name of the project, or the project number, is PR slash, or rather hyphen 001. I attach an ARC here, the Revit version, so I know what type of Revit I'm going to be opening up with. And I like to put a V1 here. Now, if you work with Revit before, you know that it's very good with revisions. So it's not really necessary for you to put a V1 or a revision number, version number there. The reason why I do this is that it's very possible, if you're working with a large team, right? And you have multiple models. Let's say, you know how graphic designers have copy one, copy one, copy two. You understand? You can lose track of the original model you're working with. So I always like to put that V1 there, to know exactly which file we are currently related to. All right. So if there really is a major revision which made you leave, or maybe the original Revit file was corrupted, then you had to go ahead and make a copy of, the new one, right? You could just go ahead and do that. All right. Okay. All right. So we have the chat is currently active right now. Just like I said, let us know where you're joining from. Very soon we'll have our stream go live on LinkedIn and YouTube if possible. So if you are joining right now, just let us know in the chat how your experience is. If you can hear me as well, also that would be great. All right, so let's go ahead and jump into Revit. All right, so I have the Revit architectural file opened up here, and the first thing I want to do is I want to quickly look through this and see. I'm not really going to be talking throughout the stream, just going to be making emphasis to some very key points here. And what we want to do is we want to do an inspection. We want to cover, or rather go through an inspection. Okay, I'm hearing the audio is low. Just want to confirm if this is from everybody again. Let's see if we can solve this in the back end. All right, let's see. Still very low. Oh my, okay. Could it be the... All right, okay. Let's hold on, see how we can fix this shortly. Okay, all right, so I'm back on right now. Just want to confirm if this is much better. Hello, Stanley. Stanley from Nigeria. Welcome. Okay, you said the audio is poor right now. Let's confirm if it's better now. Just turned off the active noise cancellation. Okay, let's be sure. Okay, so the audio, this has been an improvement. Let's be sure about that. Okay, from Stanley. Stanley said the audio is better. Let's just get a few more chats in and see if this has been improved. Okay, we have Olaiwola from Portugal. Welcome to the stream. We're really glad to have everybody here. All right, okay, great. All right, so if at any point in time the audio drops, just let us know and we'll work on it. Okay. So let's go ahead and work with this. Oh, audio. This audio is it's a bit tricky at the moment. Let's be sure. All right. Okay. Okay, I see. The audio is quite low on my end here. All right, let's see how we can fix this. Okay. 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 I think this should be much better. Surprisingly much better. All right, so just okay, yeah, this is perfect. Great. All right. So like I said, this is more or less like an informal stream. Don't really have somebody working the back end with me. I was able to, put one or two things together. You know what I mean? All right. Okay, great. So let's jump back into what we're meant to do right now. Okay. And by the way, if there is any other issue, let's just know. We're all learning from here, and it's best that we all get the best quality out of it. All right. Great. So right now we're doing an architectural inspection, and we are going to look at the key things that are inside this model. The key things that are inside this model here has been improved. Okay, just want to respond to the WhatsApp community group chats. Drop a little bit of an emoji there too. All right, great. Okay, good. All right, so we're looking at this model here, and we just want to look at, the key important details. So just going to just pan around. So I have my 3D view. Now, a quality of a model if the sheets have been placed. So let's assume that this particular project right now is in the planning stage. So meaning that the working drawings haven't been completed. We don't have all the dimensions, details, and all of those things that we need to work with for construction. If you want to pass it for approval, get permits from the town planning people. But the same way, as long as the model has some sort of form or geometry, we can actually take a look at it and start. So it means that we don't necessarily have to wait for a full working drawing before we actually go ahead and start our own structural framing or scheming. So I'm orbiting around, I'm in the 3D view here, and I'm just going to look at what we have before we jump into the plan views. I like to do this because makes it better for me to see what's going on, because in the plan views, some of us have worked with the traditional drafting softwares or maybe using the PDF, you may not be able to catch some details compared to when you actually do it in Revit or in 3D view. So I'm just taking a look around and I'm seeing what we have, and you can see um, it's a fairly simple residential layout. Here I can see that we have some sort of underground utility. This is the 3D view, by the way. It's just going to find where it's referenced in the project browser. Here we go. It's my 3D view. This is the default 3D view. So you can see it's in this curly brackets here. All right. Okay. All right. So I'm just going to go ahead and use my section box to see what's going on. Just going to turn on my section box here. There we go. Now, the reason why we also do this as well is that we want to make sure that there aren't any errors from the architects. We're human, and we're prone to make errors as well. And if there are errors, it's important not to go ahead and modify somebody's work without informing them ahead of time. But if it's something that is urgent and needs your attention, you need to work very fast. You need to bring it to their attention. Okay, so we have something here in the basement. We have this particular stairs leading all the way upstairs. We have another basement level here. We have the stairs. So it's good that we see circulation. If these circulations were missing, we have to note it out. So we have another basement part here, and we can see here that it seems like the circulation is missing or is hidden inside this topo solid that we have here. So we could go ahead and fix this before we jump into our own structural model. All right, so that's the basement level. I'm just going to go ahead and click here to move this section box up. So right now we should be on the level above. I have no idea what is being named at the architect. We'll get to that shortly when we look at the elevations. So I see we have some beds in here. Ideally, whenever you see a bed in an occupancy, you're assuming that is a living area or a bedroom. So we have a bed here, we have a WC, so baths here. We have another bed here, so that should be a bedroom. We have some cabinets or storeroom. I have no idea what that is until we jump into the plan view. I believe this should be the living area. Probably here where we'll have the audio system, the TV, all of that. Let's see what is going on inside here. Okay, we have another bath inside here as well. Very interestingly, we can see here that these two levels, this floor is not on the same level. So we have some sort of step down here. So this, oh, I see. This is a different grade from this here. Okay, that's interesting. We'll have to take note of that when we're doing our skimming. And over here we can see, okay, this is the area that leads to the basement. But it seems like we've got some sort of issue going on here. It's created a void. So I can see there's a shaft here. Okay. Okay, I see. So it has the top offset of 300. Probably that was incorrected. So I'll change this here to 0. Oops. Let's put that here at, let's say, minus 200. It's not meant to be cutting the floor. Still cutting it up. So let's say minus 500. Okay, great. Good. So that should only affect the basements. Great. So you can see where it's leading into. All right. Okay, it's rather a larger apartment. So we have another living occupancy here. And it seems like there's a shaft here that's affecting what we can see. So this as well, I'll change this top offset to minus 500. There we go. All right, great. So this will reduce the front and back that I'll be having with the architect most of the time. Okay, so we can see this is the area that we were just looking at shortly. And if you're a bit confused most of the time, you can always limit your section box. So I'm just going to go here and make my section box in bits here a bit. Good. There we go. Okay. Makes it much easier for me to work with. All right, great. So we have here this area that should lead up to the basements, but it seems like we can't see it. So it's a topo solid that is actually not allowing us to see the stairs. And if I guess correctly, there should be some sorts of elements that affects how it's cut, because if you click on the support solid here, you see we normally have this option here to subdivide the elements based on an existing one. So I'm just going to go ahead and bring this down here. Okay, so this is, we have a shaft here already, and I'm just going to come here and press the tab key. This is still the support solid. Press the tab key again. This is the shaft. Press the tab key, still the shaft. Support solid. I want to select the floor. Seems like I can't select the floor here. All right, great. Let's just go over here to the basement floor and see what's going on. Okay, this is a shaft. Press tab. Still the shaft. And let me just go ahead and delete that shaft. Great. So this is what I wanted to select. Okay. All right. So these are some of the issues that you really want to get right. You can see here that the floor covers this area here. So I'm just going to come here and click on edit. Oh, I see. So it probably should start around here. Okay, great. So modifying this, well, the reason for this is because we need to start. All right, but if it's a major change, you need to always, inform the architect about it. So just going to go ahead and see. Now we can see we have this staircase leading all the way up. Just going to bring this shape handle up a bit. Great. So we've been able to fix that issue. Just come over here and turn off the section box. All right. Okay, so let's go and turn on the section box. Probably I've noticed by now the section box is one of my favorite tools to use in Revit. Can easily switch and look through views easily. So I'm just going to come drag this down. Let's look at the first floor. So, yeah, by the way, because we have an international audience, so anytime I'm referring to first floor, I'm referring to the floor above this floor. So this is the ground floor. So this is the ground floor, and then this is the first floor here. We will also see what is named in the elevation views as well. Okay, so here, what I want to look at is this suspended floor. Is everything on the same grade or is it on the same level? So you can see, if I click on this slab here, we can see this is placed on the level which is called first floor and it has no height offsets. Let's see, we have this floor as well. Okay, so this is a roof. That's very good. You can see this roof is also placed on the first floor. It also has some slopes because you can see some points on it as well. So first floor, that's great. Okay, great. So all of them are on the same level. So that's important. We want to check for that. Okay, all right, good. So we have a bedroom here. We have some sort of accessibility to the toilet or restrooms. We have a wardrobe area, I believe. Should be a wardrobe area we'll see properly in the plan views. We have some sort of lounge here, another bedroom, and I'm assuming this should be a balcony. Okay. Then over here seems to have, what's this? Okay, so it's a column. Okay, it's rather a large column. We have the sitting desk area here as well. All right, good. Okay, so I see that this particular first floor can be accessed inside from here and also can be accessed from this stairs here. This is, I see it. So it's a fire escape staircase, so it's not your traditional concrete. So at some point we would have to ask the architect, is this going to be console, meaning that is it going to be cantilevered or supported on the wall? Or are we going to have some steel frame structures, supporting it from here as well? All right, so let's look at this, and seems like a fairly simple model until we actually start. And let's look at the roof. That's the roof on the other floor, on the other level here. So that's the topmost roof. So we can see here we have the roof. We have some sort of opening here as well. You can see we have this roof level. Okay, we have another roof here. We have another roof here. Okay, great. So I've seen some sort of coordination issue. Probably this will be pointed out by the person that will be coordinating the drawings. We have this wall exactly where this opening is. So it's probably this void will have to be moved away when they are coordinating. You can see we don't have the issue with this here on this side. Okay. All right, good. So this is the 3D view, and this is one of the advantages of working in Revit. You can easily quickly verify and look at your model, before you actually go into the documented views. Now I'm going to come here. This is the views tab and see all the views. Now it can be hard to understand which views you need to work with, and that's why I think I said earlier that it can be a joy if the architect has already placed them on sheets. It's easier for you to walk through it. So let's work with these sheets because they've done that. So we can see the first sheet here is the basement floor plan. And we can see, just going to close these views up. All right, so we can see here. Okay, so that was that stair that we are looking at earlier on. So I always kind of like to have a 3D model open so I can reference what I'm doing part time. So I have these two tabs open right now. Okay, and I'm just going to type WT to look at the two views side by side. So it's going to come and show you how you do that. So you have this option here called tile views. So you tile the two views side by side. If you want to go back to tab views, yeah, I promise this wasn't going to be a tutorial, but he ended up turning into one. So here we have this staircase. If you're like me, when I started off, it's kind of hard to find where something is. I can easily just quickly reference. So this is a sheet here, and this is a viewport. So I'm going to double click this viewport to activate this up. I'll click on this staircase and then come to the 3D view. You can see it's still selected here. I'll type BX. That is the section box shortcut here to see where that is. So with that section box turned on now, I can make that a bit bigger. I can see where that particular area is. Okay. All right, so that is the staircase here. Okay, great. So let me see. This should be leading to. Okay, so this basement here. All right, great. Just always good to understand what is going on in your project because It's a large plan. It's a large plan from what I can see. Okay. All right. So we have one section here. And let's go ahead and quickly do some dimensions and see how wide or far apart this drawing is, or these rooms are. So this occupancy here is almost about 6.77 meters wide. You also want to check if you're working the right project units. So I'll come to manage, come and click on project units. So everything that I'm measuring is with respect to millimeters. Don't want to shoot yourself in the leg and, not be able to check that properly. So just going to measure this. All right, this is about 5.4 meters. Okay. They look small, but surprisingly, they're actually large rooms. 2, 3. All right. So, like I said, this is not a full working drawing, so those dimensions are not there right now. So you want to, as a structural engineer, do your due diligence and check this. So let me just use the dimensions. So this is the wall center to wall center dimensions I'm doing just to quickly have an idea. Okay. Okay, I think I got the door instead. It's 2.5. 2.5. All right, good. So I don't think we should have an issue here. So all these walls will probably have to be basement walls. So these are going to be lateral load-bearing walls as well. They also help to support the foundation in some way. So I have this section of the building here. All right, so let's just go ahead and check. So we see we have the stairs leading all the way downwards. These are some of those architectural models that can be very hard to understand if you don't have a 3D model. This is a large room. We might probably have a beam coming in here if we're not going to be using a flat slab system. So we'll see how that works out. We'll probably use a thicker slab to support this. All right, let's check this here. Use permanent dimensions to see this better. So some of these are wall to wall. We're not really being too specific yet. Just want to have an idea of what we have. Okay. All right, so this is also underground as well. Okay, seems good. So I'm just going to go ahead and delete all these dimensions. Okay, great. So good thing as well is that you can see the architect has also linked all of this properly, so we can easily see this from the elevation. So this is detail 1 on sheet 201. So if we were using the sheets, we could reference it as well. So if I go ahead and open this up, you can see how it looks like from the north view. All those details are very, very helpful. So let's go to the basement floor. So what you can see right now is these are blown up drawings, I believe. So if I double click and open this up, I make a selection, I go to the previous sheet here, which is 101. You can see this is here. Okay. All right, so these are just blown up drawings that enable us to see this much better. This would be more useful, especially if you are working with PDFs, I believe. All right, so let's go here. I believe all these basement floor plans are just blown up views. Blown ups. Okay, good. We can also see we have some available sections as well. I see in the blown ups also we have the areas of the room. Okay, that's good. That would have saved me the time of doing the measurements. Although we still have to do the measurements actually to know the length and breadth of the rooms. So the ground floor plan here, this is the level just above the basement. I'm going to double click to open up this viewport. Okay, as you can see, that's first stairs that was leading to that first section of the basement we looked at earlier on. So we have these rooms. DI, shortcut for dimensioned, using the align dimension tool. Okay, it's about 5.6. I wonder what framing system we're going to use here. It seems easy, but when we actually start to frame, we'll be able to see how this works better. Okay, this is inside. I believe this part should be outside the building. To 550. Okay, most of this should be fine. Wow, this is a large living room. Okay, it's about 10 meters. Still possible. And we have a column here as well. I would try to do the dimension from the column first here. all the way to the top. Okay. I want to be sure exactly what this column is, so I'm just going to type BX well after selecting the column, and I'm just going to select this section box and just drag this down, okay, and see exactly where it is. Okay. Okay. Oh, I see. So this is the same column here on the ground floor is also on the first floor as well. I see. Okay, so this will probably we'll convert this into a structural column as well. All right, let me just turn off the section box here. Okay, we have some smaller columns here also. Okay, let's go ahead and see. I think these are outdoors, so I don't think I need to do section box. Oh, okay. Carry this particular feature outside here. And one would think that this may not be the job of a structural engineer, but really it is. So we'd have to actually consider this in our scheming as well, and also in our design. Okay, so this will, I believe this, what material is this? So let's go ahead and check this out. Okay, so it's wood, dimensional lumber. I'm going to ask if this is the actual material to be used. Let's just go ahead and check the physical properties. If yeah, okay. All right. See, compression values are rather low. Might end up using a different type of wood member, but let's see how it goes. It's not really carrying so much loads, but irrespective, we may still want to consider something that can carry the loads better. So, all right. Let's see, we have some columns. So back inside here, we're still doing some dimensions. And we don't necessarily have to dimension everything. You can use your eye to gauge. So I can see clearly that this is the largest room here. So just by looking at it, I have an idea of how big or how small the other rooms are. So really not going to spend so much time here. I've already been able to find my largest, and if possible as well, my smallest occupancy as well. Probably should be this area. So I'll select all the dimensions, remove this. Keep in mind that this is still the model the architect is going to be working with, so you really don't want to rough it up. Okay, so these are the blown up views. Just going to go ahead and check a look through this. Okay, ground floor plan, everything is fine. Great. All right, good. First floor plan here. Okay, so it's exactly the same thing we looked at. Just going to close up every view. So this here, this roof for the first floor, this roof here. Okay, so I have an idea of where this area is. Okay. All right, so we probably can have a beam span here, but the issue is we'd have to find a way to place a supporting element here. See how that works out for us later. Okay. All right, so just add this small dimensions. All right, good. Okay. So that's our first floor plan. We also have the blown up views as well. Okay, that's good. We have the roof plan. It's a bit self-explanatory here. You can see that's also the roof plan blown ups. We can see the elevations. Okay, so this elevation here is not descriptive, so we don't know exactly what we're looking at. So it's not been detailed properly. So what I'm going to do is that I'm just going to go ahead and open this up, click on this wall, and I'll come and open the default 3D view. So it's on the exterior, so I should be able to find where it is. Okay, nothing is selected again, so let's select that wall. So okay, so that particular elevation is looking from this direction. Okay, so I believe this should be from the other direction. Alright, so yeah, this direction here. Okay, so it's quick referencing. Okay. Alright, so we have these ones here. These are the side views, I believe. All right, so this side, so I'm assuming the other one should be this side. Okay, yeah, should be this side. I see. Here we go. Seems we have some other elevations as well. Okay, so these are framing elevations in within the building. Let's see where this is. So I'll click on this wall, and I may have to actually, create a section box. So I'll type BX again. I see exactly where this is. Oops, Control Z, bring that out. I drag this down so you know it's on the first floor. So I'm wondering why they created a section box for this view. I mean, a framing elevation. Oh, okay, I see. All right, great. So if you look very closely, you can see here that these two floors are on different levels. You can see they are on different levels. So to access this particular area, you can see this slab here. This first slab here actually is on an elevation of 0 from the ground floor, while this one here is at an elevation of 400 from the first floor. Oh, sorry, from the ground floor rather. I can also see that this was not actually done properly, so it has to actually be fixed. So you can see a stair leading up the way here, but it's not really covered. So let's see if we can help the architect fix this up. All right, so just going to go ahead and go to the sheet view, ground floor plan. Oh, okay, so this is the area here. All right, so I did the boundary. Okay, so should be here if I'm correct. Okay. All right, good. Now we have an issue saying the two floors are overlapping. Two floors are overlapping. Oh, okay. This one goes in when it's meant to be going out. So select this one here. So ideally, this should start here. I'm not going to attach this floor. Okay, good. So we can see that warning is gone. Those two warnings are gone here. All right, this might be a bit frustrating, but we really want to do this ahead of time. If not, you pay for it when you start doing your skinning. All right, good. Okay, so here we are at this particular elevation. So we see that area here. This leads up to the stair. Then this one here, I think I know where this is. Just going to select this wall and this door. BX again. Okay, I think I have found it here. So this is where the stairs is. Okay, so I want to go ahead. All right, so once again, welcome to the stream. Let's know where you're joining from. I think I took this a bit in. Yeah, let's know where you're joining from. That's how you're finding the stream right now. If you're learning wonderful things, let us know as well. Okay, so we can see this floor here is at an elevation of 400. This is at an elevation of 0. This is something that I might not have seen properly if I wasn't in the 3D view. And if it wasn't done, in the working drawings, you normally have to put an elevation mark or a spot elevation mark on the slab for us to know what floor is at what level. Also, you can check in the sections as well. So let's see that. Okay, let's go into the sections. Okay, so well, we need to understand what section we're looking at here. The problem here is that it doesn't have any description, so we don't know what section is what here. So the best way is to probably go through the plans and see where those sections are. So that's the best way to use the section since it hasn't been detailed yet. So if I come here, I can see a section through this basement floor. Okay, so apart from seeing the basement floor, we can also see the whole building as well. So this section will also be consistent in other views. So let me see if I select this wall. I believe it's, yeah, should be able to see it. select this wall, go back to that section. Okay, so this is the section of the building we're looking at. Okay. All right, let's look at the views. Okay, so we have this section. Just going to close this excessive views so we don't have too many. So we have this chair. All right, so this is the parts of the building we're looking at. Okay, let's look at this section here. Let me assume. Okay, yeah, that's that. Okay. All right, so that's just looking through the drawing, and just go ahead and look at the 3D view again and understand, the document properly. All right. I can also see that something is missing here. Probably they didn't add a roof to this particular section. I don't believe this is how it's meant to be. I'm going to suspect maybe it was hidden, so I won't hide this view. There's the floor here. Okay, so the floor is not hidden. Oh, okay. So this shafts, so minus 500. Still shaft still not getting it, so let's say minus 700. Let's say minus 900. Okay, all right. So there is a slab here. All right, good. There we go. Okay, great. So we've gone ahead and looked through the section. And another thing we also need to as well check is the width of the walls, the exterior and the interior walls as well. And so let's just go and check the basement. So just going to do a quick dimension check here. All right, so 300 mm thick walls. Let's see the interior walls here. This is a 225 mm wall. I believe this should also be the same as well. I can select one of the walls and type SV to see all the similar in this view. So we see I have total of 5 here. This one here, SV, have some here as well. I'm just going to check the thickness. So this is 150. So this should be probably partition wall. And if this was done properly and not by assumption, you can click on the wall and check the layers. So I'll come here. So you see here that the concrete itself, the masonry wall, the block wall is 125. We have a plaster layer of 12.5 on the 2 sides. So that's about half an inch on 2 sides. Okay. All right. So we have it. So we have an idea of what type of the sizing of members we use. So this is the basement floor. Let's go ahead and look at the ground floor as well. Anytime you have so many views open, I always like to click on that close inactive views. Makes it easier to work. So here, first of all, oops, mistake. I want to check this wall thickness. Okay. All right. So that exterior wall there is about 300. 300. So I can just select one SV and check. So most of the exterior walls are 300. We have this curtain wall here as well. So we want to try our best to avoid placing members here. So probably we're going to have like a cantilever slab around this region here. Okay. Let's see. This here should be the 225. So I'll select this. Okay. Them in these regions. And the 150 have them in these regions. Okay. All right. So the first floor plan. You can check them as well. So normally I could just select this and check the name, but it's not being given the name here, the type where I can see the overall thickness here. So I have to check. So SV. All right. These are the these are the 225 and these are the 150. All right, great. Okay, good. All right. Okay, so we've looked through the drawing and we have a good idea of exactly what the structure looks like. Just want to be sure I'm missing anything here. So we're doing the architectural inspection. Now, it's very possible that, you're working with an architect that doesn't want to share with you his architectural model. That can be understanding. Probably doesn't want you, or doesn't trust you enough, with data integrity, or, it's work or plagiarism, all of that. He will send you a PDF. All right. So we could also look at the PDF as well. So inside documentation, I've gone ahead and added the PDF here for it, assuming that was sent. Okay, so we have the PDF drawing here, and if it was exported properly, you'll be able to see the size that was used. So over here, this is a 42 by 29.7 centimeter page. So this should be an A3 size. You can see on the title block as well is also indicated. But it's always good to actually check on the PDF software that you're using, because when you send this will be used to scale, and also the printer or plotter settings as well would work with this particular size. Okay, now if this was exported in Revit and you linked everything properly, the callout tags, you can see you can easily switch between views, say in the PDF software. So this should work irrespective of which PDF software you're using. So if I want to go to the roof plan, I can click here, go to the roof plan. If I want to come back here and look at this elevation, I can look at that. If I want to come to the basement floor, I can click here, I can look all throughout as well. You can also see in the PDF software, we don't have the luxury of looking at the blown up views. So if you zoom in here, it might be a bit hard, especially if you have this printed already. Even if you are working in the PDF source, it may be a bit hard. So you can see that this is here A101. So this is the next blown up view. And you have this option, this view reference here. So we can see the view after this match line here. So this is a 2D view that comes after this particular building. So downwards here, we have another view. If you want to go back to the previous view that we're just looking at, that is this view here. You can see here that is detail 1 on sheet 101A. So if I click on this takes me back to sheet 101A, and this will be detail 1, I believe. Okay, so I want to come to the view afterwards here. Click here. You can see this is on this view here. If I want to go back to the previous view, here. Okay, great. So it's very important that you understand your drawing very well. And if all these details are not here, it can be very hard to work with. Try if you have a PDF. So before you start, you have to make sure that the architect provides these details for you. But the added benefit of having a Revit model is that you can easily query and see things that are missing, fix them if they are not going to heavily change the model, and then, continue on. We have some sections as well. So these sections should be linked also. We can see the sections of the building. That's good. Okay, great. We have a little call out here. Just one trying to understand what's okay. So it leads to this particular section, I believe, because of these stairs. So if I click on the call outs, great, we can see this section. And then we also have an framing elevation that we can use to see this building. Okay, all right. So the whole drawing is linked, and you can also check the bookmarks as well to easily navigate to the views. So we have the names of all the sheets here. They're not very specific because it's not been properly documented, but this should allow you to easily navigate through the sheets and look at what you want to look at. Okay, all right, great. All right, so we're done with the architectural inspection. Let's take a bit of a break and let's hear from the chat if you're enjoying this. Let us know what you're learning as well, and some things that you would also probably have questions on. I'll probably actually have the time to entertain it before we go into the scheming of it. So let us know where you're joining from here. Glad to have everybody on the stream again. All right, let's take a quick break. Okay, all right. Okay, so just went and had a quick coffee, and we're going to go ahead and continue. All right. So we've been able to look through the architectural documentation here, and we see every detail that we need. So we're just going to go ahead and start the structure. Well, okay, we have some messages here. All right. Oh, thanks. We have Hirambi from Uganda. Thanks for joining. We have Henry from Nigeria. Victor from Kenya. Thank you. We have Yusuf. Okay, thank you for this wonderful session. It's very informative. I really appreciate this, guys. Thanks so much. All right, let's jump back into Revit here. Okay, so we have our architectural model here, and we've made some changes, right? It's not significant changes, just some changes to enable us to actually look at our work with our model better when we enter the structural aspects. And we're just going to go ahead and save this. So I'm just going to press Ctrl S and save this up. It's very important that even though the changes are so small, that you have to actually inform the person, the original designer as well about them also. So, they can work, they can understand that their model has been changed, right? So I've saved this, and I'm just going to go ahead and create a new structural model. Okay, new structural model. So we don't do the structural within the architecture. That's something that we need to understand when we're working with Revit. Try for some of us that are experiencing Revit for the first time. We do it in a way where we create a separate file, and we now link this architectural model into the new model that we created. Sounds a bit tricky, but let's try and put that into practice right now. I'm just going to come here and click on File. I'll come here and click on New, and then come here and click on Projects. I'm going to go ahead and pick a template. So templates are quite useful, help you to actually start off faster. So I have this structural templates as customized by our company, and I'm just going to go ahead and start a new project and click OK. All right, just going to go ahead and load this up. Okay, great. So I want to save this. So Ctrl S to save. I'm going to choose the folder where I want to save this to. So just going to come to my computer. No, desktop actually, so I can access the downloads folder. That's where I'm saving everything. All right, so found this here, PR1. And here, I'll first of all open this architectural folder, and then I'll click on this document once, right? When I click on it once, I'm going to go back. And then you can see the name here has been changed. So what I'll do is I'll just come here and change this here to STR. Great. Okay, so we can see that this is now the structural model we want to save. I'll come and create a new subfolder inside the project folder here. All right. Good. So let's open up that folder, and then I'm going to save the Revit file inside here. So it's a Revit project file. Come to options, leave the backups as 1. I don't really want too many backups. And I'll regenerate this thumbnail preview. And I want it to always show this cover page here. So if I save it, I should be able to see what's up. I'll choose this cover page. So I understand my template. So I know the view that I always want to see as the thumbnail. So to save this, just want to be sure I chose the right cover page. There we go. So we save this. All right. So it says it's been saved. And if I come here, so we have the structural. Let me just go here, and I'll just kind of modify the name. So architectural comes above structural. All right, great. So we have the file saved here. If I change this here to large, so the thumbnail is not visible right now, but by the time we start saving, we'll be able to see that thumbnail come up. All right, good. So inside here, this is just the cover page, is the sheet view. So this template already has it has a sheet set, and it has some sheets already available. It has sheet categories as well. So if I expand this, I have my cover page, I have my sheet list. So a list of all the sheets that are currently in the projects. I have my general notes as well. So we are currently in the scheming aspect here. We're not actually designing at this point here. We want to see how we can arrange the structural elements. So we are not going to change anything inside the general notes. We normally tend to do this when we are approaching our analysis and design. Take for instance, now we want to specify the code that we are using. We want to do that under the details for structural steel. have for concrete as well. Foundation, all of these details. So we want to change it to the code we are using. Look at these details very well and align it with whatever code or whatever instructions we're meant to use. So I'm not going to touch any of this. We have S100. This is my plan views. So we can start here. We can start placing views inside here. All right. Well, let's not jump into the sheets at the moment here. Let's go ahead and open up the 3D view. That's always the best place to start when you're working with a structural project. So come to the 3D view. All right. Now we have an architectural link. So I'm just going to come to the Manage tab and now come click on Manage Links. And here I'm going to come and click on Add, click on Revit, because it's a Revit model. And I'm going to look for the architectural model. There we go. Make sure you don't pick the backup. The original file is what you need. Yeah, see? So we selected that. I want to make sure that this is set here to internal origin to internal origin. So I'm using the same exact position where it is in the architectural to match with the structural as well. If you miss this, you are in for a big headache, trust me. So I'm going to come here and click on open. Oh, so I see I can't link it because the model is currently open. Let's just go ahead and fix that. So just going to go ahead and close this. So I can't link when the architectural model is open in Revit. So now I'm back into my structural. Just going to come here. I can also, instead of coming to manage links, I can right click here and click on new links. And I can quickly just select the okay, all right. Sorry about that. We lost some connection for a bit, but we're back in right now. Okay. So let's go ahead and continue. So I'm going to guess that we didn't catch this particular part, so I'm going to do that again. So let's assume we didn't have the, okay. So we'll just come here, Revit links, go here and click on new link here. I'll select the architecture, then click on open. Okay, great. So we have our architectural model inside our structural project file. You can see it looks a bit different here. It's much more simplified, enabling us to work much better. All right, good. Okay. So in the 3D view, I want to quickly get rid of some things here that I feel might be a bit hard to work with. So for instance, I want to get rid of this topo solid here. I'll press tab. So I'll just come here and now type VG, shortcut for visibility graphics. If you're not used to the shortcuts, you can come to any of the view properties here, click on edit. Topo, we don't need the topo solid, I believe. So we can just see our structure the way we want it to look. Okay. I just got a very funny comment. So what happens when you get a PDF instead of an architectural model? Do you start modeling from scratch? Unfortunately, yes. But thanks to AI and some tools, right now I believe there are some particular plugins or scripts that you can use it to, automate and create a framing for you from PDFs or CAD files. Although the disadvantage from that is that it takes away human creativity. So yeah, you actually have to, be very careful. Most of the times you end up doing more work even using those tools. So yeah, that's just how it is. Okay, so here we have this. And we're just going to see if the model looks correct. I'm orbiting downwards as well. All right, this seems good. Okay. So let's go ahead and save this. All right, so save the file here. Now, the next thing I'm going to do is I'm going to come to the Views tab, and I'm going to come and look at my elevations. That's what I normally want to start with here. So we already know the elevations that were used in the architectural model. So we want to bring those in or match them with the ones we already have in the structural model. So this here is the Revit link. If I select it here, I can go to 3D view. You can see this is the same model selected like this. So before I even continue, I want to pin this. A very frustrating thing that can happen is if you mistakenly move it out of place, right? And that can be very frustrating because all your elements will be misaligned. So I'm just going to select it, and I'm going to come here and click on this button here, pin selected element. So I can use the shortcut PN. You can see now that there's a push pins on the model. So if I try and move it out of place, it does not even allow me out. So the same thing as well in every other referencing view. So this here, I have first floor, ground floor, basement floor. Also have the natural ground level as well, NGL, that's what I was referencing. And then inside my Revit project, I believe I have 2 levels here. I have ground floor, and then I have the top of footing. So what I'm going to do is that I'm going to bring the ones that I don't have inside my project. So just going to come here to the Collaborate tab, copy monitor, select link, and then I'll select this link here. I'll come here and click on copy. I'll turn on multiple. Now, what this does is that it enables me to quickly bring in this element without having to model it from scratch. So I'll select this, hold down the control key so I can make multiple selections. I'll select the roof floor. I'll select this first floor. We already have the ground floor, so I don't have to select that again. I'll come and hold down the control key, select the basement floor. All right, so I'll click on finish. There we go. And I've brought in those levels. So I have to come back here and click on finish again. All right, good. So we can see those levels are now in within the projects. And if you're a bit confused, you can just go ahead and select the Revit link. I'll use the shortcut EH. That's the shortcut to quickly hide an element. So you can click here and click on hide elements. By the way, this is a good time for me to actually talk about keyboard shortcuts. So Revit has a lot of shortcuts you can use. So for instance, as you're typing in a shortcut, like for instance, I just typed in key. So unlike your CAD software, AutoCAD, where you can see it in the command line, you can't see it in Revit. Or that's what we thought, right? If I come here to the bottom, we have what we call the status bar. So if I type key, you can see keyboard shortcut K just came up now. If I type key S, sorry, let me do that again, key S, you can see keyboard shortcuts comes up. So you can see all the mapped keyboard shortcuts that are in Revit, and you can also create keyboard shortcuts as well to quickly work within Revit. So click here, I'll type EH, which is to hide the element. I'll bring it back shortly. I can see these are the levels I just brought into the project. So these 3. And these are the 2 that were already inside. You can see these ones already have referencing plan views because they are blue. These ones don't. I'm going to come here and unhide my Revit link. So I can see the one in the project here is at 450. While this one in the Revit link, I can't select it, right? So to select it, you have to come to the Revit link. So your mouse or cursor is going to show you what is currently highlighted. If I press the tab key, I can now go ahead and select an element within the Revit link. So we can see this one is at 600. We can't change it because it's from the architectural. So what I'll do is, first of all, I'll align this to this. So I'll select this ground floor. Now change it here to 600. I'll click on apply, so they're on the same level. Likewise as well, I also want to change the name of this level. This is all in caps. This is not in caps. So I'm just going to come here and change this here to ground floor. All right. Do I want to rename all corresponding views? Yes. All right. So that's not enough. We also need to monitor it with the architectural model. So you can see the ones that we imported. If I click on it here, you can see they are monitored. So if it changes in the architecture, I'll be notified in the structure. So I'll come here, copy monitor. I'll select the link again. I'll click on monitor. So I want to monitor the level here, then match it to this one in the Revit link. So if this changes, I'll be alerted on this. Click on monitor again. I think, okay, yeah, so I want to do that with the NGL as well. So first of all, I'll cancel this copy monitor. So we see this one here. Because we canceled, we didn't accept the monitoring. So I want to match this top of footing here. I mean oh, okay, I know where the confusion came from actually. So this top of footing is not what we're matching to any of this. So NGL, we need to bring that in as well. So I'll come back to copy monitor, select link. I'll come and click on copy, just the NGL. Great, the NGL is in. Then I'll come to monitor. I'll monitor this, then click on finish. There we go. Now to remove the confusion, I can go ahead and hide the Revit link again, EH. And now we see all the levels are in the project. So I'll select this ones, just want them to be aligned. So know what we're working with. Let's just add this bubble here at the end. I don't need the bubble here. I'll drag the extents on this as well. There we go. So we have the roof plan, roof floor 84, first floor 46, ground floor. I can just come here and add an elbow, raise it up above so I can see what's going on. And 600 NGL as well. You can see all of them have the heart pole symbol. Apart from top of footing. Top of footing didn't exist in the structural or in the architectural, so that's why we don't see it here. Great. So I'll go to every other referencing elevation view as well and make sure that they are all aligned. These are the things we need to take our time in doing before we continue. So here, match this. All right. So once again, if you're just joining us, let's know where you're joining from. Let's know how you're enjoying the stream as well. Also, feel free to grab a snack. This is basically watching a full project, come to life. The point is to prove that it is very possible within Revit. And, we want to make sure that everybody understands that this can be done. All right. All right. So sorry about that. Apologies. We lost our transmission for a bit. Okay. All right. So we're aligning the levels. There we go. Right. So we want to make sure that we are as neat as possible. We'll still end up doing most of this again, actually, but at least for the starting point here, we want to be able to see our details Much better. Oops. So we've done that for the north, done that for the east, we've done that for the south, we've done that for the west, and just going to go ahead and clean them off. All right. So I like to check if everything here has been properly modified. Then yes, you can see they are all straightened out. So I can now go ahead and unhide the Revit link. So unhide it. Okay. All right. So here, hide the Revit link. Okay. All right. So yes, here we've been able to do that. All right. So let's go ahead and bring in the grid lines. So to bring in the grid lines, we need to first of all create the views, the respective views that we need. All right, sorry about that. Just needed to get something. Okay. So we need to bring in the respective views. So in this template here, I only have the ground floor available. So if I open up the ground floor view, you can also see we have the Revit link here. Okay, so we only have the ground floor on top of footing. Let's go ahead and bring in the first floor, the roof floor, and the basement. So if I come to the view tab, I'm going to see the plan views. Click on the structural plan. And I want to bring in the basement floor, the first floor, and the roof floor. All right. We're not bringing the NGL here. That's just something to, as a detail to show on the elevations. So I'll come here, make sure that they fall on my GA. Yeah. Plan. All right, great. So we have all of those in view. We can also see the elevation marks as well. I want to make sure that they are aligned because these are the ones that came with the templates. I want to make sure they are aligned with the projects. So I can make a selection and I can move them closer towards the projects itself. All right. Make a selection over this. There we go. So you can use this elevation mark to easily navigate to look at the views from any of the sites. All right. Great. So you can see everything has been reflected on the plan views. So we have the basement floor now, first floor. All right. We have the ground floor. We have the roof floor, just like that. So imagine having to do this in CAD, you understand? I really don't like to think about it. So some cases it's inevitable, but you know, having to do this here, Revit is so much more relaxing. So here, like I said, I don't need the topo solid at all. So what I'm going to do is that I'm going to get rid of the structural layouts. I mean the topo solid here. So I'll come here under view templates because this view currently has a view template. I'm going to come here under visibility graphics, override for the model and click on edit. Then I'm going to come here and summon topo solid. All right, so sorry about that. I had to quickly attend to something. So here I'm going to turn off the topo solid here. Okay, great. Yeah. So now we can see it's better. So on the basement floor plan as well, we can also see all these details have been cleaned off. All right, so I'm just realizing now that we don't have grid lines. So let's see that here in the architectural model, we don't have any grid lines as well. Now, naturally, the architect should be responsible for creating the initial grid lines here. We would have some structural grid lines as well. Well, if the architect hasn't done that, you understand, you have to let him know that, okay, he needs to create them. But he gives you the go ahead, especially if you are the person coordinating the models, you can go ahead and create those grid lines from the scratch. He would have to copy them into the architectural model. It's not always the ideal scenario, you understand, but to work faster, that's probably the preferred. So I'm just going to go ahead and look at my model and see the farthest towards the left here. I always like to number my grid lines in this direction with numbers, so numeric, and then in this direction, I like to number with the alphabet. So I'm going to come here and go to the ground floor plan. Can see the farthest on this side here. And here it seems like the model is not complete a bit. So the reason for that is that this has been optimized to look at the structural plan. So this template here, I have a view where I can look at my coordination better. So I'm going to come here and turn on this coordination view, which enables me to see my model much better. All right, good. So we can see here this black region. It's probably because it's cutting through the slab. Okay, it's cutting through the slab here. That's because these two floors are not on the same level. So I'm using this DS18 coordination here. So I'm going to come and modify this plan a bit. So let's see, we have the DS18 coordination here. And we have this view range setting. Okay, so that's exactly what I wanted to change. So since it's turned off, it's in Revit, I believe I should be able to change it from here. All right, good. So you see the cost plane is set at 300. So I'll set it to minus 300. Oh, so, oh, no, minus 600 rather, sorry, something higher. So this can be above this, so let's make this higher. Aha, better, much better. Okay, good. I also want to get rid of the topo solid. I don't know why I didn't modify these templates to get rid of the topo solid. So I'll come back here. I'll come and click on this temporary view settings, this coordination that we have here. And I'm going to come and click on model and come here and turn off the topo solid. All right, good. So we can see here that right now we can now see this view range has come back to what it is because we just modified it. So just come here and change this back to 600. All right, great. Much easier to work with. Okay. Okay, went for a quick water break. Let's go ahead and continue. So we're going to place the grid lines now. And the grid lines are going to be at the building. So I have the farthest wall here. I'm just going to go to my structures tab, click on grid line. And I have this grid line that I normally use. I want it to always fall at the middle of the wall. So I'll click here. And I'll drag this grid line further out a bit here. Great. So this is labeled R. So I want to change this to let's change this to should we use letters here? Let's use 1 here. So this is 1. So this grid line, we'll be able to see that in every other referencing view. So if I come to the basement floor, we can see that here. If I come to the first floor as well, we can see that. If I come to the roof level, we can also see that as well. And if you can't see that, then you have to go to any of the elevation plans and make sure that they are cutting through all the elevations. So that's that. And I want to drag this all the way down here. Great. There we go. You want to make sure you don't have so many grid lines. So I'm just going to select that, type CO for copy. I'll paste this one here. I want to check the dimension between these two grid lines. It's 4 meters. All right. So I'm just going to go ahead and place other grid lines as well where I see they can be placed ideally. Okay, went for a little bit of pause, just logged in to see the areas where I can place grid lines. So the idea behind placing grid lines is that you really don't want to place a lot, just enough to work with. Okay. So we have some other referencing grid lines as well that we might need to place, especially for views that we can't see. So for instance, here, this basement floor plan. So I'm going to go to the basement floor. Okay, good. We have one here. I may have to have one here, actually. Probably one here as well. So just going to type GR, which is short for grid line. Okay. Straight where we have the major walls. All right, so having an issue placing that, so I'll use my align tool. There we go. So this don't have to extend all the way to the top as we saw earlier on. And we'll see how we can adjust that in the elevations. We can see we also have another place here that we need to take note of. GR. So this can just focus on these particular regions alone and not the whole building. Let's see what happens if we move this to this. So 5. Look, sorry, ground floor where we were. So 5 really doesn't align with so many here. Okay. It was only aligning with this small wall here. Let's leave it as it is. We'll see how we can work with it later. Okay, so you can see this is grid line 11 here, still showing on this. Okay. All right. We can always place grid lines later on as if we need them. So I'm not going to really worry about numbering them at this stage. So let's go ahead and place the grid lines in the other directions. The problem now is label these ones. Okay, yeah. So we'll label the other ones in this direction here. We'll start from A downwards, then go upwards. I prefer to come downwards and go upwards. Some people prefer to go upwards, downwards. Actually, it depends on the orientation of the building. So if this is the front face of the building, I like to start my letters from here. That will affect how I look at the sections later on. So let's start from here, this little area. Come to the basement floor plan. Okay. And I can also turn on the coordination view here as well. Good. Makes it easier for you to see what you're doing. GR. So this one here starts from this wall. I'll name this as A. This is B. Great. Before I continue, I want to go to the ground floor and then adjust for these areas also. So GR C. Can put in between these intersecting walls here. There we go. Have a major wall here, so we might need to have one here as well. So you can see this, the last one was H, so G. So this is going to be I, so don't need to worry about that for now. We can always remember it later. Okay. Then let's go and see the basements. So this region here, let's see if this aligns. If not, we'll have to create. Great. So this aligns. This is always a joy. This is always a joy. We don't have any grid line here. This is a major wall. GR for this. It's also important to note that not all these grid lines. It's also important to note that not all these grid lines would have to be on every level, so we have a way to adjust it as we continue. All right, let's place a grid line on this wall here. You can see the importance of checking the architectural drawings before you start, right? So I know for a fact areas that I need to avoid. So like for instance, this particular wall, I know is an external wall here. If not, I would have been placing grid lines to align with it as well. That should normally be covered under the civil drawings, civil structural drawings. So I don't have to worry about them for now here. All right, so we have one here. Might be excessive to place two grid lines on these two walls, so I might just place one in this partition wall here. All right, great. And so let's go ahead and look at the basement floor plan. All right, this fits. Okay, let's look at the first floor plan. I'll come here and turn on the coordination view. This is a good indication that most of the walls have been aligned. This is the joy of most structural engineers. You want to be sure they are aligned. So as you're framing the structure, it's easier for you to align columns as you're going upwards, so you don't have so many columns that you're introducing on the floor. Right? So those will be acting as point loads on beams, and most of the times we want to avoid that as much as possible. All right, great. So we've seen how we place them. It seems there's a section, this particular major wall here, we don't have any grid line now. This is a major wall. It does need a grid line. It does need a grid line. So we can come here, GR. Okay, all right. Sorry about that. We lost connection for a bit. Thank God I noticed that. Okay. So, right now, we've been able to complete the grid lines. We've not done anything actually. We've been able to complete the grid lines. From here, we can now determine how we scheme the structure. Let's go ahead and look at the default 3D view. Oh, I should save the project actually. We've done a lot. Okay. Now, if we did that correctly, you can see as well, creating new files is giving us a backup here. At some point, we'll be able to see the thumbnail or preview of what we're doing. All right, good. So we can see this is the 3D model we brought in, and we already have the ground floor. We have the first floor, we have the roof floor, and we also have the basement floor below as well. And all of these have this coordination view, so I'll restore them back. So we can only see the levels that we have for now. So here, there we go. Okay, all right. Thank you everyone for the patience. We're back on now. All right. So we're 12, if I am correct. Yeah, we're 12 minutes off, so we can end the first session here. Now, please, I do hope nobody has been on a chokehold. It's not a training of any sort. Feel free to grab a drink, you understand? Snack, breakfast. I myself have not had a proper breakfast this morning. I just want to kind of replicate how it feels like to do a structural design from scratch. Not that it means I can't have breakfast before, but we're just laid back and actually looking at this properly. All right, so we're just going to clean up these views a bit, and here I'm just turning off the temporary. I'm turning off the temporary view properties. So we had this here before, this coordination. So I'm just going to restore this. This is one of the advantages of having a good templates. You understand, you can easily walk through it. Now in the views itself, I don't want to see the Revit links. I only want to see it when I'm looking at the coordination view. So what I can do is that I can come to the template applied. Now this is the template that I use for my plan views. So I'll come here to visibility graphics overrides for Revit links, click on edit, and I'll turn off that Revit link. So for every view that has that template, it will not be visible. So in the process of trying to scheme, I can just come here and turn this on. I can look for where I can place my columns and beams, and when I'm done, I come here and then just restore this. You can see for all the other views as well, they've also been reflected. I also want to do this as well for my elevation also. So I'll come here. This is the template I use for my elevations, so structural elevations. I'll come here to visibility graphics for Revit links. I'll turn this off, click on apply so we can see it go in the background. There we go. All right. So now we're just left with our grid lines and our levels. The 3D view is fine to leave this here. Okay, no, in 3D view actually you want to turn this off as well. So right now I don't have a template on this view. I have a good reason for not having a template here, but I can at any time always apply this 3D structure. Well, I'm not going to apply it. So in the 3D view here, I can just come to visibility graphics overrides. I'll come to filters, Revit links, and then I'll turn it off. Now for the 3D view, I have this 3D coordination template. Great. This is a much simpler view for me to work with, and I can easily, look at my elements. Now the small issue I have here is that I can't see the physical elements properly. Let's try for the framing elements, the timber elements, and steel elements. So I just need to update my templates. And some of you that might have had this issue before, this is something that can be quite frustrating if you don't know how to fix it. So I just need to change this here to medium. Okay. Oops, not this. What did I do? Okay, I applied it for a different template. So this is the 3D coordination. Okay, so I just come here and change this here to medium. There we go, much better. So I can just go ahead and restore. All right, and just before we head off for the break, I always tell everybody, especially people that I train, mentors, mentors as well, mentees, that your presentation is very, very important. So I'm going to come to the sheets. I'm going to come to the cover page, and the cover page actually shows us the project overview. Now I have the title block here, and I have a viewport. So I'm just going to go ahead and double click the viewports, open it up, turn on the crop region visible, and then I'm just going to try and center my project a bit, just like this. So what will happen is that as I'm modeling it, all the elements will be showing up inside the cover page. So just going to come here, and I'll turn off the crop region visible, click on apply. Turn on the crop region visible, click on apply, double click. So this is the title block, this is the viewports. So I just want to align them properly. I'll type MV, align them properly. There we go. So we have the model. Now inside this viewports here, I'm going to change this here. I have two templates. I have one for presentation for construction drawings. I have one for approval, so I can easily distinguish what drawing I'm looking at. So we have the construction, we have approval. I'm going to change it to approval. There we go. All right. Then, because I changed it to approval, I need to change my title block to the approval. Great. Good. All right. So we've been able to update, and as we continue, we'll do the scheming here. We'll get to see how we can modify and look at views properly, see the framings. We can also as well look at the schedules as well. We have a particular deliverable where the client is currently asking for the quantity of structural framing elements. They want to know if this project is above their their budget. You understand? It doesn't make any sense to complete a design and the clients can't afford it. So they want to be sure that it's within the scope. So that's what we're doing right now. The scheming, the general arrangement drawings we provide for them before they can make a decision and say, oh, let's go ahead and further with this project. All right, so we're done with the first session here. I promise I wasn't going to say so much. I hope I don't do that in the next session. And we're going to see ourselves 2 hours from now. That should be 1 p.m. West African time. Thank you everybody for joining. The window, or rather the projects, you feel free to look around it and see if you want. And if you have questions as well, let me know in the WhatsApp community and in the chat as well. Sorry, what I meant to say was that the studio will be open, so you're free to ask questions as well. We have moderators that will also be answering your questions as well. Ibrahim says thank you as well from Car. I really appreciate. Also, if you're just joining, let us know where you're joining from. Send you some cheers as well, and look forward to seeing everybody 1 p.m. West African time for our next session. Okay, I just want to confirm if you can hear me, so we avoid the whole mic incident again. So let us know if you're joining. Oh, by the way, we're also on LinkedIn Live as well, so if you're joining from LinkedIn, feel free to drop a message. Let us know where you're streaming from. Okay. All right, so just a quick recap of what we were able to do during the first session. We looked at the architectural model. Let me just go ahead and pull it up again. Oh yeah, we're actually on it right now. So we're able to look at the architectural model, which is what I'm currently viewing as well. We looked at the 3D view. We looked at the sheets as well, the plan views, the sections, the elevations, and all related details inside here. And after that, we went ahead and created a structural model, and from there we're just going to go ahead and continue from where we stopped. So just go ahead and load the structural model. All right, this is it. And now we want to go ahead and scheme. So we want to arrange our structural elements. So before we continue, I just want to make sure that our Revit link is still loaded. You can see right now, if I come over here and then click on links, it's unloaded. The reason being is because currently it's open. So if I close it and I don't make any changes, I don't believe I made any changes to it, I can come back here, right click, and then click on reload. All right. Okay. Yeah, so that way we have our architectural model linked back into our structural model. Okay. So let's go ahead and continue. Now I want to go ahead and scheme. Let's go ahead and scheme the structure. Okay. Okay, alright, so now let's go ahead and start scheming our structure. So I always like to start off with columns, structural columns. I'm going to go over here to the ground floor plan, and this we should actually start from the floor that is on the lowest level. So here, the north view, you can see our lowest level here is the basement floor. So I'm going to go ahead and open up the basement floor, and I'll come back here and turn on the coordination view. Okay, so from here I'm just going to go ahead and scheme how I want the structural elements to be. So I know for a fact that this is 300 mm thick. That's the foundation wall. Now, that doesn't necessarily mean we need to have our foundation wall 300 mm thick. So for instance, I just hold down the tab, select this wall. If I click on the edit type, when I click on edit, you can see the layers that are used for the wall. So here, unless it's not been properly detailed, that's something we should also check as well. So we can see this is brick, fiberglass, masonry block units. So yeah, this has obviously not been updated. This should normally be fully concrete, so we're going to assume that this is fully concrete. So we'll also as well put a revision note as well on our drawing to confirm what's the layers, if we're going to have an insulative layer, membranes, all of that, soundproofing details. But for now, we'll assume everything to be 300 mm thick. So I'll come to the structures tab, I'll click on wall, that's what I'm going to be using, and I'm going to go ahead and look for a 300 mm wall. If I don't, I'll pick an existing one, click on edit type, and I'm going to go ahead and duplicate this. So I'll call this 300 mm. Then I click on this and then change this here to 300 mm thick. So material is very important as well. So throughout the project, for most of the materials, I'll be adopting the C2530. I may most likely change this for underground structures, probably in the design stage, maybe C3037, but for now I'll just adopt this. Okay, so once I've done this, I'll go ahead and click OK. So I have this new type here. And with the new type, I'm going to go ahead and set this to height. So I want this all to go to the ground floor. So I'm currently on the basement floor, so it should go to the ground floor. Alright, so let's go ahead and scheme this. Draw a line from here to this point. We have one. So yeah, maybe a little bit elusive, but it's actually there. And that is why we have our 3D view. There we go. So the elements that we just created now are there. So we have this spanning up to this point here. So just going to go ahead and scheme this out. Type CS, create similar, and create one up onto this point. So there we go. We have our basement wall. The structure is taking shape. So the span between these two walls here are quite far apart. We're going to be looking at how we can support the suspended floor above. For now, let's not worry too much about it. Now, I want to put a grade slab here. Now, this particular slab here, is going to be acting as the foundation. Okay, so we'll be adopting like a raft slab onto later specified, when we have a geotechnical report. So we'll just come over here to structure and then click on floor. And I'm going to be using a 250 mm floor type. So I'll have it 250, so I'll edit, duplicate. And by the way, all of this we're just assuming for now. During the design, we can go ahead and determine what the suitable sizes are. I would use this out of experience. Okay, so 250, and there we go, that's fine. I'm going to click on this and I'm going to create an offset. So I want it, because it's a raft slab, I don't want most of the forces to be at the edges. I want it to offset out a bit. So this is on the basement floor. Give it an offset of 600. So I'll create it from here and I'll come over here and stop. So we have it stopping somewhere around here. It's going to support the flights of stairs a bit, just some backfill. Oh, you know what, let's just leave it. Just a little bit of a small allowance. Let's leave it like this. So I'll click on finish. There we go. So it normally does come with this span direction arrow, especially if you don't turn it off when you're creating slabs. So I'll go ahead and delete it. So I go to the 3D view and this is what we have. Okay, going back to the basement floor plan, let's look at this region here. Okay, so I'm just going to select the existing one and CS to create similar, and then I'll create basement wall like that. So we would have to place an opening inside this basement wall because there's a door here. So let's see, we have this here up to this point here. There we go. You can see this is going to eat out of the staircase details, so I'm going to use my align and tool and align the face of this stairs to this wall. These very small details would matter in coordination. Great, good. So go to the 3D view. Right, so you can see everything in real time here. I'm going to go ahead and create another slab. Let's just come and click on floor. Oh, okay. Oh, apologies. I'm just saying here that the music is a bit too loud. I didn't notice that. Okay. All right. Sorry about that. Okay. Just want to confirm if this is better. If this is better. Okay. Thanks so much, Victor, for that observation. Didn't know that the music was going off. Okay. All right. So let's go ahead and continue. Audio input device. Okay. Okay. So here, let's draw a wall. Floor rather. I'll change this here to 600. Once come and stop here first. So it still has to support this floor as well. So I'm just going to draw another one here. And I'll just remove lines I don't need. Oops, not just good. Then I'll just trim and extend everything together. So this is all. Yeah. Okay. So I'll just combine. Give this an offset of 600. Big line. Okay. this. All right, great. We want to just get that 600 offsets on corners. So let's go ahead and save this. All right, going back to the basement level. So this is the last region. I'm going to go back here, click on wall, and just come and create a wall boundary. There we go. We have one here, one here, one here. So I have this coming up to this point. There we go. Okay. All right. So we've the basement floor. So I'll just go ahead and install this. And you can see this is the original template plus how the wrap slab looks like. You can see how the basement floor is as well. Most likely we will need some sort of walls to break this span this direction. So let's go ahead and look at it again. So I'll just come back here. Probably we could place the wall in this direction. So this one's have to be 300. So I'll just type CS up to this point here. Okay. Apologies for the break in transmission. Just had to make sure that that was sorted out. Okay. All right. So here we are. We're back on the basement floor. So I just skimmed this. And the reason why we placed this here is that we are realizing that, we may need some sort of support going all the way to the top here. So it all makes sense as we, go forward. But this wall is far wider than the suggested. So let's go ahead and just check the dimension of the suggested. 225. So let's create a new wall. So we can come here, edit. Let's duplicate this. There we go. All right. So obviously for reasons we know, we can't have this go all the way down. Let's go ahead and have it here. We can have another wall here as well. So CS. Just help break the span. And would add openings where they're needed. So we could probably just have a beam at the top to support the slab. And that should be able to take care of this basement floor here. Let's look at this region here and just check the dimension between the floors. This is 6 by 5. Okay. With a thick enough slab, the suspended floor should be able to hold. So that side is fine. Over here, need to find a way to break this span. So just going to go ahead, come back and click on this. And we're just going to go ahead and pick the 225, which is the one we're using. And let's see, we have one here. This is quite far from the next one where I was thinking of placing one here. Let's place one here. This wall is far thicker, far less thicker than what we need. This is 150, but I don't think it's a good idea to have a structural wall of 150 mm thick. So let's stick with the 225. So we would have that in our structural notes as well. So we placed one here, we placed one here. Let's look at the distance from here to here. See if we need an intermediate one. It's 8. 8 should be fine. Should be fine. Especially considering the fact that on top we have a suspended slab. So let's go ahead and place one here. So in the process of analysis, we'll know which one we can actually eliminate. Okay. All right, so this is the scheme for the basement floor. So just going to go ahead and save this. All right, so that's easy as that. So we come back here to the basement floor plan. Let's go ahead and restore this view. Okay, so let's go on to the ground floor. Good thing is that on the ground floor here, we can see a preview of what we did on the basement. So we have an idea of how to support it. So I'm going to come here and then turn on the coordination view. Okay, so this coordination view, still remember that I have to change the view range here. Let's change this as so this is where we have the foundation also. This is going to be a suspended slab, so we need to find a way to close it up. So since this is 225, I'm just going to come to the structure style, click on beam, look for a 225 mm beam. Let's say 225 by 600. This is what I'll start with. So creating a new type here, 600. So I'm considering 600 because I believe that length may be too long. So from here, I'll draw it into this point. There we go. Let's look at the 3D. All right. So let's look at the length of the beam. Okay, so that's about 3 meters. Okay. 3 meters. Let's go ahead and duplicate. So 3 meters should be fine. Let's use a 400 mm beam. 400 or 450. Let's see, mm. Deep beam. All right, that should be able to be fine. So we have this plan from here. Let's go back to the basement floor plan. Let's do a quick dimension from here to here. It's about 5.3 meters. That's still fine. Okay, so this is how we're supporting the slab that's coming on top. So if I come back here to the ground floor now, we now have to look for a way to place columns here. So we're going to start over here by clicking on columns and have this family for columns here. So I don't believe I have a 300 by 300, so I'll start with this 300 by 450. I'll duplicate this. Mm. Here we go. And I want this to go to a height all the way to the first floor. So I place one here. It's always a good tip to start at the corners of the building first. Place one and place one. So as you're placing these elements in Revit, you want to be sure that they are supported. Alright, so the elements are properly supported. So these columns are far apart. We might need to have another column in between. So let's see. We can't place one here. Or rather, we can't place one here. We can't place one here rather because there's a door. So I'm just going to select this, copy, and place one here. Let's see how far apart they are. It's about 6 meters. And probably we might need one more here. There we go. Oh. All right, let's see if we can do the same thing here. So I'll copy these 2 columns. All right, good. Now the tricky part here is looking for how to support it here. So if I come back here to the ground floor, this is where we have our supporting wall and beam. So these are the only areas where we can actually place columns. We can't place a column in this open room here. So let's go ahead and check the dimensions. Again, so this is 5, 5.95. So likewise as well, this here is 8.3 meters. So we probably need a column in between. 8 meters for a beam that may come on top might be too long. Okay. We can't place a column here, so we need to find a way around it. So let's say we have a wall. We already know we have a wall here. Why don't we place a beam going in this direction? So I can just come back here to Structures tab, and I'll come here and click on beam, click here, and then come up to this point. There we go. So this is exactly what we have, just like this. So the only issue now is that the beam is going to be showing from the surface, especially if we do not have a recessed ceiling. So that's something we'll put in the coordination notes. So now we can afford to place a column here at this intersection. All right, now here obviously we can't use this 300 by 300. It's way thicker than the wall. Let's opt for a 225 by 225. We can't use a 150 mm column. I believe that is too slender. So let's just opt for 225 by 225. So we have a 230 here. I might just duplicate this and call this 225. 25 mm. All right. Here we go. All right. Always looking for solutions. Okay, so we can afford to place another one here inside this wall. Here, just enough. Okay. And here, we can't, I would prefer that, the columns go straight, but we can't afford to place one here because there is a window. So let's just go ahead and borrow this. And let's place at this intersection here. Okay. Come to think of it, let's look at it properly. We could have this beam moving a bit. So if we come to the ground floor, let's say it aligns with this wall. Okay, no, it can't because we're looking for a way to support it. So some things have to give and take. Okay. Okay, we can actually. All right. So I'm going to split this. And here, let's say, is there really a need? I don't believe there really is a need to do that. So I'm just going to check it. 6 meters. Okay, I don't really think there's a need to do that. We could always change our scheme later on if it needs the need be. Okay. All right, good. So we've been able to place columns here. And the good thing is that if we come back here into the 3D view, if we come and then turn on the 3D coordination, we can see this is just a story above. So there isn't necessarily any much loads that are going to come in on top. So we do have this roof slab here. But apart from that, we don't have any loads coming on top of it. Okay, great. Let's go ahead and save that. And I'll come back here to the ground floor plan. Let's move over to the main building. So you see we have a 300 mm wall here as well. So I'm just going to go ahead and copy this. Might as well place one here. This one here. Remember to always check 3D view. All right, good. So this is far away from this basement wall. So these will have their own separate foundation. So no need for concern here. Let's go ahead and copy this. Let's see where this one lands. Okay, so it's exactly on top of this. So this column will not need a foundation. Let's come back here. Let's see how far these columns are spaced apart. It's about 7.7 meters. Let's say we place a column here. All right, good. The intersection there is a safe point because we're sure we won't have windows here. We'll still check. We shouldn't have windows in between there. This is about 6.463 meters. Let's add one here at this intersection. All right, good. We're doing good. Okay, so coming back here onto the ground floor plan, moving into the main. Let's try and align it with this column here. So I'm just going to go. And I'm having a hard time aligning, so I'll just place it here first. So obviously this column that we place now is going to be okay, great. It's exactly on top of the wall. I thought it was going to be inside here. All right, that's good. That's good. It's just going to eat out of the cabinet area. So what I'll do is that yeah, let's leave it like that actually. Let's leave it like that. We might have to indicate that this is going to clash with it, or if we change it to a 225 by 225, so it's in the process of just brainstorming. Okay, it's really doing almost nothing to this wall. So come back to the ground floor. So it just eats a bit out of the cabinet. So let's try that instead. Okay. So you can see this is where the basement wall ends before we need another foundation again. So something to keep in mind. Let's come over to this region here, see how we can support. There we go. And probably one here. It's a tricky structure. We're doing our best to make sure that we can align it as much as possible. Window here, curtain wall about 4.7 meters. Probably with the next column we'll need should be that's about 6 meters apart. So probably we can move this about. So the dimension here 5.8 still fair. So if I move this here, that's more leverage. This is the area that I'm looking for a way out. So this has to be a full open plan. It has to be a full open plan, no columns. I don't even believe this is something you can debate with an architect. So yeah, this is almost about, let's say, 40 square meters. I'll see how we can sort that later. Okay, so let's place a column here. These are the smaller walls now. Just going to use the match properties tool. So align our columns best as possible. So we are not even having any beams here at all. So 3D view, good. So good. So now we have a column here just above this. So we need to look for a way to support this with a beam in the basement floor. So I'm just going to select that column. And I'm going to come to the ground floor where it's referenced. So should be a beam from here to here. Just going to turn this off so we can see. All right, so you can see this is just suspended above nothing. I'll use BM, my shortcuts here for beam 2. And here, this could be a 225. I think I misspelled this. So let's call this 225 by 600. All right, so this beam here is about 5.5 meters. So I think that depth should be sufficient until you analyze actually. So if you look at this, yeah, this is exactly what we were trying to capture. Okay. So let's go ahead and turn on the coordination again. A bit frustrating about this view range. I really don't want to add it to the templates because it's going to affect other views. But we can just change it when we need to. It's better than having nothing as well. Okay. All right. Let's see. We could have a column at this corner here. Okay. Seems to be a bigger wall. So let's go ahead and opt to use the 300 mm. I'll use my alignment tool to align them together. Okay. So we have a bigger column here. We don't have anything here at this corner. Let's place one here. I believe this distance is a bit too far apart. Say 4.3 meters. And we have another 4.1. This is 6. 6 still feels a bit fair. I'm going to leave it here for now. So a good thing to note is that the columns don't necessarily have to fall on the they don't have to fall on the foundation. I mean, sorry, on the sorry, what am I saying? Okay, great. So I meant that the columns don't necessarily have to fall on the grid line intersections, is what I mean. Okay, oh, so I just got a message from Ibrahim on the chat. Okay, his mic is making some sort of noise. Okay, apologies for that. Let me see if I can fix that. Okay. Okay, all right. So I believe that was a cow glitch on my part. the mic should be much better. Okay. All right, so moving back inside here, we have quite a number of columns already. Normally, we want to make sure we can eliminate the columns, and not have too many columns, but sometimes it can be inevitable. So let's continue and see. Okay, so let's say we place this one here. For the change of hearts, let's say we can place this here, and instead we now move this one to this side here. There we go. All right. So moving inside here, we can place a column here, and let's place one here. So, let's place this at this intersection here. Okay. There we go. All right, so we have a grid line intersection at the window, so we can't afford to place that column there. So why don't we place it here instead? Let's place one at this intersection. Place this one at this intersection. Okay, and then one here, one here. All right. I'm just going to select some of these columns like this. And I'll copy to this point. This here, we can use this 2 to 5 here. Okay. So, we've been able to support, or rather look for ways to place our columns. We have quite a number of them. Now, the ones that aren't resting directly on the foundation here, we want to look for a way to support them. So what we'll do is that we'll come back here to the ground floor plan. I'll turn off this view, and I'll look for a way to frame them. All right, so here, we could just make them aligned. So this here just almost touches this column. So, it's be like a waist actually. So why don't we just, that's the ground floor, extend this outwards a bit, and then I'll align this together. I'm also going to turn on my coordination view to make sure, it still falls within a wall. That's what we do. Want to make sure we save as much material as possible. So now for the others, we could just use a simple foundation. Okay, so if we go ahead and look at our elevations, we can see some of the elements already in place. We have our top of footing to be exactly at -1.5 from the ground floor. Then also as well is 1.5 from the natural ground level. So from the ground floor to the top of footing, we should have about 2,100. Okay, 2,100 mm. That's 2.1 meters. So I'll keep that in mind when we're creating our foundation walls or foundation beams in this case. So I'll come back here, and just going to come here, come to the structures tab, click on wall. I'll select one of these existing, click on edit type, duplicate, and I'll call this 2.1. We might still change this, and I'll do this by 300. So the only thing we're changing here is the width. We're going to start with the exterior ones first. Okay. All right, good. So in this case here, since we're on the ground floor, we're going to be going to the depth. We're going to change this level here to not basement floor. We're going to change this here to top of footing. So we could go ahead and start here. There we go. If I click on this, that is going to be the foundation for that particular point there. So we can connect this to this basement here. There we go. So we still have a building here. Okay. Seems like, okay, the alignment is out of place for this particular column, but for the rest, they're fine. So let's see if we can fix this. You know what? I might just change this once and for all. Okay. So I'm going to add this view range. Where's the view range? Yeah. So the view range here. Let's go on to 600. Oh, my bad. This is not the plan that I wanted to change. Okay, so this is what we're looking at here. If there was a way, okay, so this is an interior column, so we could just match it to be like the others. Okay, so let's connect the others. Still using this 3x1. We have these two columns unsupported. And slightly off. Let's see how we can change that. Okay, so it seems we can't align this. We have to move it down a bit. Okay, this can be moved. This can be notched down. I think that would be the preferable option. So we're going to align this beam to this face, and then align this here. There we go. Yeah, great. All right. Okay, so this part of the structure as well would also be using a raft foundation. We also need to kind of put some beams in between to give some stability. So what I could do is that in the 3D view, I could also continue my drawing. Let me connect this one here as well. Can connect this here also. This is a wide open plan. I wonder why we have this here. So let's check it out in the 3D coordination view. Oh, sorry. 3D coordination view has this topo solid. Let's go ahead and remove that. Okay, so this beam here is going to be supporting this slab. And this is a very, very wide slab. So we need to look for a way to break the span in between. So coming back here, we can as well also copy this. And oh, you know what? No, instead of copying, we already have a beam here. So is this a beam or a wall? Okay, this is a wall. Let's save material and copy this instead. There we go. So that breaks that span, helps it out a bit. Okay, so we have the whole building connected. We want to make sure that this falls under it. So just going to drag this out. Just going to drag this. Oh, the walls are overlapping, I see. Okay, so I'm just going to align this wall here, this. Okay, I'll just switch how they join then. So this little icon here to disallow the join. And then I should have more control over this. So probably it's because of the intersecting what do you call it, wall. So let's go ahead, we'll leave that. We can always come back and look for a way around it. The most important thing is that this is here to support it. Okay, so in between, let's place some beams. So all of these are going to be in grid, on the grid, so we don't need to worry about them being visible. Alright, so in the 3D view here is also a very useful view. You can go to the structures tab, click on wall, and here I'm on the ground floor going to top of footing, so I can use all these columns as references. Alright. The only issue is that you may not really have as much precision as you want, so you have to use the alignments too. Okay. Just going to copy. Alright, so I broke the span quite well here. And you know what? Looking at it here, this may be too big. This beam, so let's go ahead and create a new one. As much as possible, we want to save materials. So let's use 225 by 21. Great. This should be much better. So we can use this 225 to close up these other beams here. Okay. So I want to make sure the whole structure is supported. All right. So now I'm going to go over here to the top of footing plan. That should be the layer where all these ones terminate. And we're going to create a separate raft slab for this as well. So over here, you have to be careful not to be confused. We can see here, we can see the raft slab for the basement here. And if we don't want to see that, we can change that from the view range. So if I come to the view range here, you can see this goes all the way down. So we can reduce this value here so we don't see the slab. So let's say we put this as minus 600. And this value also has to match it, so it has to be lower. So let's say minus 600 as well. Okay. Just want to make sure. So this is minus 600 from, seems like that is about the same height. Oh, okay. Wow, they are quite close. Okay, they're rather close. Okay. Because of detailing issues, probably the best thing to do is to just go ahead and hide them. So these ones here, just go ahead and hide them. EH to hide. Or you know what, let's leave them out. And I'll select them. This is kind of like a detailing technique. Select them, right click, override graphics in view by elements. Oops. Select the 3 rough slabs, right click, override graphics in view by elements. Oh, I'm hiding in view by elements. Override graphics in view by elements. Great. Thought I was running mad there. Okay, so I'll come to projection lines here and I'll change this pattern here to probably an aligning line. I think that's good. Now I'll change the color here to this. I believe the weight as 1. Great. So it tells that this particular slab is not on this level. So now I can focus on this slab on this that's meant to be on this level. Alright, so here in the structures tab, we're going to still use the 250 mm thick floor. And just going to come here and create a boundary. So I'll use this peak line here. And then I'll set this here to 600 to offset on the sides. So I'll select this wall here. We'll trim all of this out later on. Oh, so this is a basement actually. So let's leave it. We'll look at how to cut it out later on. Can't really remember where is where. Okay, this is basement as well. I know for a fact this is the basement, so we can stop it right here. Let's move this offset. Then this line here, we can attach them together. There we go. So I'm trimming the corners out. So this basement, I'm not really sure where it is, so we can adjust that in the 3D view. So we have some lines that haven't been trimmed. Okay, so it came with this span arrow, don't want that. So I'm going to go to the 3D view. So we can cut off the parts we don't need. So in the 3D view, I'll click on edit boundary. And ideally, it should be here. We don't need this, we don't need this. Have it here, up to this point here, it's fine. Okay, so this is the staircase region. There's going to be an opening here. So we want to be careful not to add one here. Alright, so staircase leads all the way to this point, so look for a way around that. Oh, seems like my chain is turned on. So if you have that turned off, you can't continue drawing your lines. There we go. Okay, so I really don't want this to be inside the wall. So I'll click on edit. If possible, they should be aligned at the edges. This will be very important later when we are trying to do our analysis. So anywhere where they are, yeah, so they rest directly at their intersections. I believe I did that for this area as well. Okay. All right, great. So we've been able to scheme our foundation. The rest will probably be very easy. So let's go ahead and look at our cover page. Remember, as you're scheming, everything will be updated here. So I can come here and open these viewports. And I'm just going to come to the templates here, and I'll remove the architectural link. So all we're left with is the actual, project itself here, just like this. Okay. Can also add some shadows, I believe. Shadows option. Seems like shadows options isn't turned on at the moment. Where is it? Okay, it is actually, yeah. So you see the shadows. All right. Let's take a quick break here. Okay. All right. So we're back. And sorry about the break in transmission. I think this is a sign for a break. Okay. This been a good session actually, and I haven't tried the structure as well myself, so it's great to actually skim it with you guys also. So let's use this time to entertain comments. If you're just joining in the chat, let us know where you're coming in from. And we'd like to know what you've learned so far. If you're enjoying the stream, if you faced any challenges, let us know. Let us also see comments as well on Instagram rather, LinkedIn Live also. Let's also see comments on the WhatsApp community. Look forward to seeing more and going forward. All right, let's just take a break and we'll continue shortly. Okay. All right, we're back. And we've been skimming. We've been skimming so far, and we already have the rafts for the main building, apart from the ones that are going to the basements here. And let's go ahead and place the ground floor slab where they're meant to be. So this would have a ground floor slab. This as well will have a ground floor slab. This part would have a suspended floor slab. This part would have a suspended floor slab. This area as well will have a suspended floor slab. So to do that, we're going to go to the ground floor plan. Just going to close any views that we have open here. And ideally, what I would do is I would have copied the slab from the architecture, and there is actually ways to do that. So if I go ahead and turn on my temporary isolate, you can see here that this here is the slab that is being used, but the problem is that it extends outwards upward to this point here, and normally we may want to use something else here. If they do intend for this to be concrete as well, we can use this. In fact, it seems to be concrete, so we might end up using this, but the whole thickness is a whole different layer. So if I come here, we can see the concrete layer itself is just 125. So all of this is just some sort of finishing, and the substrate as well, the hardcore. So we will just go ahead and use a 125 mm for the ground floor slab here. So I have that selected. So I just want to go around and check. I'll go and turn on this coordination view, so we can see the outline of where the slab is meant to be. So we have it all the way to this point here, just after this wall. So this will extend out by 2 meters. So that's floor is going to be resting directly on the ground, on the grid here. All right, so if it's quite too far, we may have to provide other beams here to support it, and there are ways we can actually do. There's ways rather we can actually support it. So we're going to look at it. All right, so just come here to Structures tab, and I'll click on Floor. Then I'll come here, click on Edit Type, Duplicate, and let's use a 125 floor type. So since it's resting on the grid, we can afford to use something of this depth. So let's start here. Keep in mind that we have some sort of step-up elevation here. We've already looked at the architectural, so we want to be sure not to miss that. So I'm just going to follow this. There we go. We know that this level is up to this point here, and I want to follow in between the walls. Very important. All right, so we have it stop here before we have the other floor. Just tracing this. All right, good. So we still see. This is the level of detail that you can only see if if you are sure. Okay. This wall might extend a bit outwards a bit. Let's just try and support it. Great. So all this other area is going to be a slabbed area. There we go. On the ground floor, let's click on finish. Oops. So there's a small portion that didn't connect. I'm just going to extend them together. All right, still a portion that is not connected. All right. Click on continue. And let's check it out now. I'm not attaching, don't attach. Let's go ahead and see what we have in the 3D view. Great. Okay, so we can see this wall still extends downwards a bit. So we can have some sort of beam support it. Likewise here as well. We'll probably need a beam here also. This seems fine. Just want to be sure it's at the right level. Great. Let's go ahead and restore. All right. So we have a portion that we need to support it with. So let's go ahead and restore this. And this came with its own span arrow. We don't need that. So I might just extend this ones down a bit. We could actually leave it without support, but it's concrete, and if you have that wide span, it tends to crack. So if you can help it, why not? Okay, so probably realize there's a faster way to do this. So I'm just going to go ahead and copy this beam here. There we go. So I have this beam. I'm going to change this here to a 225 by 21 beam. Going to align them on the sides. Extend this one out a bit. There we go. Then select this one as well, copy this. Bring this one in. There we go. Alright, so I'll come here and click on this tool, trim extend to corners. So I'll click on this wall, then select this beam so I can trim all of them to quickly merge with each other. Okay, so here we might have an issue. Or do we? Okay, we might have an issue here. All right, so it seems that this particular floor here on this level steps down by 400. So thank God we actually observed that. So probably when we come in for the next session, we can actually change that. So there we go. All right, so the floor on this particular level here is at an elevation 400 mm lower, I believe. So let's go ahead and check. So I'll come back here, 3D coordination. I'm going to first of all select the Revit link, HI, to isolate. I'll select this one. Oh, okay, so it's this that is 400 above the ground floor. All right, so now that we've clarified that, let's go ahead and restore. What that means is that this particular slab here should be at 400 mm. So what that means is that every beam in that direction as well needs to be stepped up by 400. Okay, so to do that is fairly easy. First of all, I'm going to cut all the intersecting beams before it reaches this part. So I'll use the shortcut SL. I'll slash this. I'll slash this one as well. Slash this. Slash this. Great. Make a selection of all those beams there. Use the filter tool. Check walls. Click apply. Okay. Great. So you can see I have a total of 14 walls. Missed one there, but we'll change that shortly. And I'm going to give them a top offset of 400. Great. Mistakenly selected this. So not this. Great. So you can see all this go up. All these other ones are where they are meant to be. So it's just a matter of adjusting the ones that don't fall in place. I missed this little one here. Top offsets of 400. I also need to cut this one here at this point. SL. Put 400. There we go. So I just need to align. So for instance, this here, align this face here. Align all the beams and faces that need to be together. Here we go. You can see everything adjusts automatically. Saves you the stress of having to do that manually. All right. Okay. Seems like we have a column that is not aligned properly, but my eyes are deceiving me. Okay, they are. It's just probably how it's joined. So let me just switch the join order. Here we go. It's an illusion. Okay. All right. So we'll place the other slab that should be exactly at 0 layer. So I'll come back here. So now the reason why they're appearing as black lines is because of the view range. So if I come to the view range here, this cuts at 400, so I have to put it at something greater than 400. I click on apply. Now we can see our beams back again. Now for the other area here, okay, so this slab, I'm going to notice Ctrl Z. I'm going to try to align these two lines together. There we go. Now attaching them in. All right, great. All right, so the other slab will be in this direction here. That should be for this whole area. So I'll select this slab here, type CS, and let's draw it out. So first of all, I'll draw on the corners. I do understand that there's a path along the sides, but we can't see that on this view here, and I haven't turned on the coordination. So I'm just going to sketch it out here first, and then worry about that later. Just want to make sure that I can get the actual area first. And there's a patio here. So my major concern is getting this intersection here. Yeah, there we go. Okay. All right, good. So once I'm done, I click on finish. Then here are the areas that I have enclosed. Just going to go ahead and finish that in. I'm not attaching, so don't attach it. All right, great. So now I can now go ahead and turn on my coordination view and see the areas that I need to extend it out by. So this is the slab that we just created here. All right. And this is the extension out. As you can see, they are showing by hidden lines. So I click on edit boundary for mine. And then I'll align my own lines out. There we go. Then you can see this. This one here. Okay, this is a match line. This is the actual slab line here. So we have this part of the slab still extending outwards here. All the way to this parts here. I believe they might want this to be concrete. So let's all leave this here. Then once they review, the client reviews it, they'll know whether or not they want to use concrete for this patio or something else entirely. There we go. All right. So just going to click on finish. I'm not touching it yet. I go to the 3D view. Great. So we can see exactly how it's supported here. So this one here is at exactly 0, but this one here is at 400. You can see how the slabs look like. Okay, so that covers this area here. We have an area that has the staircase, and we want to make sure that we put a shaft there. So that's this particular region here. So what we're going to do is that we are going to create a shaft along that region. So first of all, we need to see it properly. So just going to come here upon on the coordination view. So if I select the slab, I can see it. So this whole area should be voided. This whole area here should be voided. All right, so normally you can actually do that by selecting the slab and then creating another loop inside it. But I prefer to use shafts instead. So the shaft tool in Revit. So I'll click on shaft opening. Yeah, I'm just going to create a shaft. There we go. All right, so that cuts through the slab. So this last part here of the stairs, this is a run. I knew this would be, and this is a landing. So this will be part of the slab. So that's why I didn't cut out of it here. So just going to come here, restore. There we go. So that cuts through the slab in the way it's meant to. I have this span direction, don't need that. All right, so this is exactly how it's going to be. So for that particular shaft, I'm going to click on it, edit the sketch, and I want everything to be at exactly the middle of this what is going to be supporting it. In this case, is going to be the wall. It's a very good reason for this. It'll save us a lot of time if we want to analyze the structure later on. All right, great. All right, that's good. Now the last part here for the suspended slab for the ground floor is going to be this particular region here. Oh, by the way, this can't actually be all. Some part of this is suspended, some part of this is going to be on grid. So the region here is going to be suspended. The region here, the region here is going to be on grid, right? The region here is going to be suspended. So I may want to adjust that later on. So we may want to use a bigger thickness. So let's use 200 mm thick floor. Then we can kind of separate the other slab out and then turn that back to 125. Let's focus on this region here. This one is just a closed loop. So just going to come here to structure, click on floor, and that's going to just be a simple slab grid there. So going to be someone can walk over it. Just going to go ahead and create it from the corners. All right, that's on the ground floor. Click on finish, don't attach. All right, great. So just going to come to the 3D view and see if that matches. 3D coordination. Oh, so it seems it's not on the same level that I expected it to be. So this is where we actually have the slab from the architectural. So it's actually on the natural ground level. So I may have to change mine to NGL here. Okay, so that means the other parts on top can just serve as block wall actually. So let's see how we can change that. Or you know what? Well, why not? Why you can just have concrete go all the way to the top instead of having block here again. So that actually is preferable here. So this one here, this one's in between, don't need to go all the way. So let's put it here at a distance of minus 600. That should be the distance. There we go. So that's the distance in. We just want to confirm that again. All right, so yeah, from the NGL to ground floor is 600. Okay, so this is our scheme. And if you're doing it properly on the cover page, you should be able to see everything. All right, so we have the Revit link here. And my templates, I'm just going to go ahead and remove the architectural link here. Great, so we are just focusing on the structural members. And another good thing as well is that I have this sheet here. So with a proper template, you can see how much concrete you already have in total. So this is just a 3D view on the sheet. I can see I have a total of 43 columns at the moment. And beams here, it doesn't give you the total, but it gives you the total length. I mean the numbers, it gives you the length here for the different sections. And here for the slabs as well. So everything is automatically being calculated for you. And here, this is just meant to be the view that shows the full structure. I'm just going to come here, double click inside here, come here, and then likewise also turn off this. Okay. So we're just focusing on the structure itself. Come here, there should be another view. So this is for, okay, the structural, this is if it has a power cap. So there will be a way to filter this so we can see the structural wall details as well. All right, there we go. All right, let's take a quick break here, far past the second session. And overall, we're just about to finish the second session, kind of trying to make it a 2-hour stream in between. And it's really getting really interesting here. And if time does permit us today, we can go ahead and do a quick analysis to show the maps, and then we can present it as well. All right, so we've come to the end of our second session. Let us know where you're joining from in the chat if you've been enjoying the stream so far. We'll look forward to hearing your feedback as well. Okay, so let's take another intermission, and then we'll meet shortly for the next stream or the next session of this particular stream. Look out for the information on the WhatsApp community group. Okay, all right. Welcome everybody back to the stream. And we're just going to go ahead and continue from where we last stopped. I've been able to skim some of the elements, and I've come and put down a checklist so I know exactly what needs to be done on this particular model. All right, so over here, this is the first checklist here. I want to indicate the suspended slab and the one on grade. So in this case here, creating a shaft won't do it. I would have to make a void in this slab. So here, just click on the top view. This whole region is going to be voided. So I'll click on edit boundary. Then I'll create another hole inside here. So from here, just going to come all the way to this point. There we go. So we have 2 lines there. So I'll delete this. All right. 6 scale there. Need one here as well. Okay. Don't attach. All right. So let's create slabs there now. Let's go to the ground floor. Should be easier to do that there. So let's just go ahead, create a floor. This can use 200 thickness. This as well. Should use a suitable thickness. All right, so this remaining here, this particular slab here, we can change it to a normal grade slab, 125 thickness. So the ones that are suspended are the ones that are thicker. Now let's adjust the beams because we have this deck here. We've already done it for this area. If I want to do it here as well, I can do that from the ground floor. You can see it more clearly.
Okay, takes care of the foundation beams. So keep in mind, we have to actually adjust the raft slab as well. And that's on the top of footing level. So just going to come back here. Yeah, so we can see all the new beams that we've added. Let's go ahead and fix this. This should come out a bit. We'll still offset it by 600. Let's make a hole in here as well. That's exactly what I was trying to avoid. So okay. As the bigger picture is much easier to see what's going on. This is exactly what I wanted to achieve. Okay, great. So we're setting up those voids. All right, so we could check this up. All right. Another thing I also noticed is that we could change this to suspended beams, save a lot of money on having this as walls. So instead of having this here, I'm just going to delete. So let me leave them as references. So I'll go to the ground floor plan. I'll put beams instead. So let's say 2 to 5 by 450 since I don't believe the span is so long. Let's see. It's about a 4-meter deep beam, 4-meter in length beam rather, 4.15. So we have one here and one here. So instead of having these walls, we can have those beams there instead. There we go. And these all have to go down by 600. So they're on the ground floor. So if I want to reference it from the ground floor, I have to give it a negative offset of minus 600 on both sides, since in Revit we can make our beams inclined. There we go. Okay. All right. So I need to join all these elements properly. So for instance, the slabs, you see this hatch line here. Just want to join them to the beams and everything that is currently on it. So I'm just going to use the join command. Click on multiple join. Make a selection of all of them. Those elements that don't need to be joined would be removed. Great. So this is exactly what I needed. So I also want to switch the join order so the beams are on top of the slab. There. Right, great. I'll do the same thing here for this. And join elements that don't need to be joined. The SJ. There we go. Likewise this here. JN, join this. So this and this. Alright, great. Seems we missed one here. This goes up by 400. Alright. Okay. Supports modified slab on grids. Been able to do that. And now let's go and model our first floor beams. So since we have columns here, we can go ahead and model the beams that should come on top of them. Alright, let me move this a bit. So this should be on the first floor here. So we can see all these columns that we've modeled here. We can see them clearly. So I'm just going to come here and turn on my coordination view. We can see the areas where we can place the columns. We also want to as well check all these columns that we've modeled so far, if they aren't passing through any opening or windows. Okay, so these are all good. Orbit around and check. That's good. Okay, so on the first floor, we're going to just try and model some beams. Sorry, bless me. Bit of a flu. Okay, just following the pattern. And I'm drawing beams here. You may not see them on the exterior, but once we are done, it will make more sense. You can't see them here right now. Drawing the exteriors. Let's see. We have columns here. And I believe we can have. All right. Okay. So if I go to the 3D view, right, you can see we have beams here. So we have an issue. This long beam here is not supported by anything. Let's turn on the section box so we can just focus on this level here. See it better. I want to change this here to hidden line to make it easier to view. So this is barely supported by anything. So we can find the beams to intersect and carry them. Okay, so going back to the first floor plan. All right, great. So let's look for a way to add those beams here. And I can do this in the 3D view since we're already here. Keep in mind here that I'm using 2 to 5 mm beams instead of 300. So in this way, we have allowance in the walls for other features that may come in later on. This is meant to be 2 to 5. Any. Alright, then this should be properly aligned. There we go. Missing a single column here. Oops. Having a bit of an issue moving them. Before we even place it, let's be sure what we have. So just going to come here, turn on 3D coordination and check. We want to make sure we're not placing those columns in a way that it obstructs. So you can see all these beams here. If you want to look at it from below, that's the floor below. Just going to drag this down a bit. So the idea is that they are overlapping over the walls here. So apart from them being supported, they're overlapping. You can see here that I've had this beam come out here. This is not necessary. So I can drag it back in here. So I was about to place a beam over here. I feel it's fine actually because this serves like some sort of lobby. So even though it's showing in the room, it's still kind of fine. Okay. All right, just got a message from the chat. I wasn't audible. Just want to check now to see if I am audible. Let me do a side check here as well. Just want to make sure I'm as audible. Oh, okay. Yeah, probably. Okay, great. I probably must have been tired back then. Okay. All right, so let's see. I think placing a beam here inside this wall is better here instead. There we go. That's much better. Okay. Okay. I'm just going to go ahead and restore. And yeah, and I remember the reason why I wanted to place one, because if there was this column here, I'm looking for a way to support, we can't just have it here without an intersecting beam. Um, let's see what we can do. Putting a beam here might be excessive. Moving the column as well. We can move the column to this intersection. Yeah, that's a better option. There we go. So if we move the column, we need to look at the implications as well. So moving this column here, does it affect the foundation? Okay, so you can see that column is still sitting on top of the foundation beam. So we can continue. All right, let's see how we can frame the other S aspects. Just going to save this. Go into the first floor plan. Have an idea of where all the beams are. So drag this one out a bit. We have a beam here, we have a beam here. And then I just realized we haven't placed a column here for this very large room. So we're going to do that. So I'm just going to first of all select this column. This is a 500 by 1000 column, but the actual dimensions is 600 by 15. So you have to be very careful when dealing with this. So here, I believe since it's an open room, this column here, I'm going to use a column with a drop panel. So that would be a much better option. So I'll use this column drop panel here. Just come to the edit type, duplicate, and let's say 600 by 15, I believe. Okay. So we have 600 by 15. And we want this to go to a height all the way to the roof floor. Okay. Let's see how that looks like. Okay, first no. We want it to start on the ground floor and go to the first floor. There we go. All right, so you can see it has this drop panel here. So that we'll use it to support some parts of these areas here. And we want this to go down to the foundation, so it's not sitting directly on the slab. So we want to change this here to basements. Sorry, not basements floor actually, NGL. So it is going to be sitting directly on the slab. So sorry, not NGL, top of footing. There we go. Yeah, sitting directly on the slab. So I would adjust the cap details on all those later. The most important thing is that we have that column there. So let's go ahead and save this. Okay, going back to the first floor. We want to create our section box again. Still in the process of looking for areas to place the beams. And here, I think I'm more comfortable doing this in the 3D view now. Okay, this part feels fairly stable. Here, okay, so we have a beam here already. So it seems like it's cutting through the floor. Just want to cut it so I don't see the slab, but I can still see the beams. Okay, now I can't see the beams. Okay, I can see the beams now. Okay. I think we could have a beam here. Would have been nice if these two could align. Or could they? So let's just go ahead and check. Okay, so if we push this, they won't be actually properly aligned. Okay. All right, so we have this section here and this section here. We can have a beam here. You know what? We could have this all the way down here, so most likely the alignments can be done in a way that this wall is pushed backwards. Yeah, there we go. Okay, so this looks fairly stable. And probably I'll add a beam that goes in this direction to keep these ones, make these beams more rigid. That's right what to use. Alright, so here this is just going to be a cantilever beam, cantilever beam, cantilever beam, carrying that slab on top. Okay. Fairly stable structure. Alright, so let's look at how it looks like. Yeah. Ground floor plan, the first floor plan. Great. Want to make sure that we don't have a panel that is far too big or wide to be supported. So here in this particular area, we're looking for a way to support it. That was an issue that we got from below, but thank God we have a slab on top. So even though that slab is quite large, it's not going to be carrying so much load. So we can just make the roof a little bit thicker but the other areas are fine. So this area here is the call for concern. We could actually have beams spanning here, right? But I would suggest, okay, so this is about 6 meters. You have 6 meters in depth. Probably let's just have this a 600 mm beam running in this direction. So we have a capital here that can kind of take more of the load. So I'm just going to come here and put a beam. All right, so that will be showing in the room. All right, so since this is a 600 mm beam, here we need to make the beam here as well 600 mm to be able to allow it. So I could just make this segment 600, or I could just make all 600 mm. Preferably just making this one 600 mm is better. So it can collect it. So just come to the first floor. And I'll change this here to 600. There we go. Much better. Okay, so let's move over to our first floor columns. So those are the first floor beams. First floor column we're heading into right now. And we can check how to place them from the first floor plan. So I'll come here and turn on the coordination view. Let's look at areas that we can have columns go upwards. We also see we have some columns here as well. Let's look at the 3D view. That's from the architectural. Okay, so we have some columns. So we could make use of this particular columns here to support the roof. So I'm just going to come back here to the first floor plan. I'll come back and find my 225 mm column. And I change this here to height. They don't fall exactly on the line. All right, so we can make them on the line just for structural stability. So it doesn't rest on the slab. You really don't want your columns resting on the slab, no matter how small it is. So come to the 3D view. We have those columns there. Then I'm just going to select some of the corner columns and want to see how high they can go. So here, 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 and here could go up. So I'll just change all of this here to the roof. There we go. Obviously, we can't have this one going all the way up. So we would need to look for a way around. Probably we need to introduce a column here. Oh, we even have a wall here actually. We have a wall. So it's possible that we can actually introduce another column here. So the first floor. Let's see that. Okay, so that particular column there on that floor. Let's go ahead and make a copy of it. Place this here. Oops, not actually here. Seems to be. Let's align it. And just change this here to roof floor. There we go. Now, supporting this particular area might be a bit tricky, so we might have to have cantilever beams. But when we get there, we'll face that hurdle. Coming to the first floor here. What I like to do is that I like to just, select all the columns first in the view. And then I just change everything at once to first floor. Sorry, not first floor, actually roof floor. There we go. So once I've changed it to roof floor, I can now go into the 3D view and look at the columns to terminate. This way, it saves me the time of trying to wonder what can work. I'm just going to come here and turn on the section box. Okay, so I know for a fact this can't work. This can't work as well. This little guy is fine where it is. You can't have this column. We already have supporting columns. We don't need this. This is excessive since this is already on the roof level. So I'm just going to select this little guys here while holding down my control key. And I'll change them back here to the first floor. There we go. This as well doesn't need to go high. This also doesn't need to go. So this was the only one along this line that could go. So I want to look for a way to align them and place them along these beams to support. So type CL for column. This height going to the roof level. I place one here. Then I'll move it. There we go. This intersection is okay. As you can see, it's placed directly on top of a roof beam here. I mean, sorry, first floor beam here. Just can't see it, but it's right there. This area here will be a call for concern. How to support it. Probably we could make a copy of this column here. We have a beam here, but there's no way we can support it. Which brings me to think maybe it would actually be preferable to actually have that beam that we were trying to avoid here instead. So, you know what, let's just go ahead and, okay, yeah, that's why we didn't have it in the first place. Okay, there is a column, I mean a beam here. So I'll put that beam here instead. So I'll move it to this line instead. There. So now we should be able to have it being supported. Right. Still kind of feel there's a need for support here, but we'll cross that hurdle when we get there. When we get to the roof, that is. Over here as well. Let's go ahead and turn off the coordination. Okay. Seems like we would need a column at this intersection here. And probably this little guy could go up as well to support that area. So let's select this. Change it to roof floor. So go to first floor and see where it is. Okay, great. Falls inside the wall. No complete. So CL and place a column at this intersection. That will just be perfect. I'll align it to fall in place with the existing. There we go. Oops, not here. There we go. All right, so let's fix this capital here. Okay. All right, so we have the capital length, capital height. Search capital top length. Let's preview it so we can see exactly what's going on. It's capital length. Let's change this here to 1,500. No, it should be bigger than what we already have. So let's say 1.8. Capital length 1.8. Let's make it a square capital. Okay. And then the drop as well. Okay. All right, so let's move over here to the first floor slab modeling. So come to the first floor. And here I think I should be able to copy what is in the architectural. So let's try that. So I'll come to the collaborate tab, copy monitor, select link. I'll select the link, copy, and I want to select the floor. So click here, brought in the floor, and I wonder if I can bring in this. So these are roofs, so that is the reason why I can't select them. I wish I could. So just click on this, how to model the roofs separately. So for the floor, here it's we need to change the type. Okay, so this is using a 150. Let's start with 150, that's fine. 150 is fine. When we do our analysis, we see what works. Now we see we have a void here, it's not meant to be. So that's because of this void we created on the ground floor. Okay, so great. It came with the void for the stairs as well, so we don't have to place that. I'm just going to come to the first floor and then modify the extent on the edges. This will help later on when we're analyzing the structure. So the way we model our structural engineers is going to be different from the way architects model. We want to make sure that every single extent is very precise. So by the time I'm done with this, it's going to tell me that my sketch differs from the original. I might as well expect that. Okay. Want it to fall on the neutral plane. Great. Okay. I have a small area here. Continue sketching. Great. So for the void as well, and here we have the roof region. So this is going to be a slab, so I'm just going to go ahead and model it. So just structure tab slab, I just use CS as shortcut to bring it up. This is also on the first floor. So because I brought this from the architectural model, it's not structural by default. So you need to, once you've gone ahead and modeled it, you need to go ahead and make it a structural element. Okay, all right. So the arrays join together. Let's see. So to join them, I'll just use my JN, join, then make a selection of all the beams. Okay. All right, just come here. All right, good. Go ahead and save that. That's our slab. There we go. Okay, so it seems what is left now is the roof beam. It seems there's a part of the structure we haven't attended to actually, which is this top part here. Yeah, actually we haven't attended to this. So this column should be able to go all the way to the top. Likewise as well, this, oh my, this couldn't go up because of the distance. I mean, this void that we have here. Anyway, we'll look for a way around it. Oops, so this can't be there. Actually, can't be there. So we'll actually have to place one on top of this beam here, which is already 6 meters long. So these are elements that will have to be highly reinforced actually in real practice. So let's come back here to the first floor plan. Let's look at exactly where our wall is and where we can place a column. So it's exactly at this point here. And let's see, the beam just below it is a 225 by 600. So we need to look for a way to increase that here. So in this case, I would make this beam that I just selected right now, I'll have to make it a 300 mm, so 300 by 600. The reason for that is because I want a column of 300 by 600 to match this wall over here at the top. So I'm just going to come here, edit type, I'm going to duplicate and call this 300. There we go. There we go. All right, so come here, CL, and I'll place a column here. This is going to change to a 300 by 300. And I'll move it here. All right, so that's where we have that. So the distance apart from these two columns is so far. Okay, the distance apart from these two columns is so far, so I would have to introduce another column here again. So we have to look at it properly in our analysis. So just come here. There we go. So now this is what we are looking at. Let's see. Probably need a column here as well. Okay, we already have a column here going to the roof floor, so that's fine. Okay, so now we have, I believe we should have enough columns to frame our roof. So I'll go to the roof floor and I'll turn on my coordination view. There we go. All right, so I love roofs because it's very easy for us to see what's going on here. And just going to go ahead and use my beam tool. Let's start with a 225 by 450 on this edge. 225 450. And we need this beam here come here, come here. Okay, so we can't have this come all the way down here. That's fine. Now, okay, let's see what we've been able to frame. There's still some elements that are far from being supported. For instance, this particular members here. This might be a tricky one, but we should be able to find a way. So we have this very long column here. It's about 7 meters long, so it's going to be carried by this column. Here it's quite a very long one, actually. So we can decide to increase the depth. So let's say 225 by 600, and it's still going to be carrying a roof beam. So this is about 225 by 600. Great. So the intersecting beam here, I've said just this cantilever beam alone should be 600, but there will be a lot of torsion here, so it must be better to split it at this point here. Yeah, so here would be a better or ideal position. So this I can make a 600 mm DP. Alright, let's go back to the roof floor plan. Over here, we have this column, so we can put a roof beam here. This area here as well. Great. And let's place a beam here. Good. Alright, good. Okay, seems like we've been able to support this. So this longer beam that we have here right now would be supported by this. So I think this would be best to change to 600. This as well, we change this to 600. Most likely might be deeper after our analysis. Then this as well, we change this to 600. Yeah, I would have said only from here to here, but I still concerned about the twisting moment here. So it's better that we have it go all the way down. Okay. This is my biggest concern here. This particular span. Yeah, I'm trying to see if there's a way to support it. Oh yeah, there is. There is. I've forgotten that we have. Okay. Just want to confirm my audio is still active. Okay. Apologies for the break in transmission. And yeah, so just looking at this, and seems we've been able to model properly. Okay, so let's take a look at this roof floor again. All right. Okay, so we've been able to scheme this well. And yeah, so I was just thinking here that this one is quite wide, but I just remember we can have the same column here as well, on the first floor. So back on the first floor, we need this going to the roof. So we have this here. So that will help to support it. So we can have a beam going in the other direction. So to do that, we can, well, we don't necessarily need a beam here. Or do we? Yeah, let's have a beam. No, let's not have a beam, because this will now become a cantilever to this, and yeah, so this will just help it to support the slab like a flat slab here. Anything else will be kind of excessive. All right, so we've done the roof beam modeling. Okay, let's take a quick 5 minutes break, and then we will be right back, and we're looking at the documentation. Place this on sheets, and after the staircase modeling, by the way, and we'll be able to export it, get our deliverables. All right, so let's go ahead and jump into the staircase modeling actually. So just going to go ahead. Just got the music playing in the background. Suiting. Okay, so let's jump back in. I just realized this panel is a bit too big. Let's see if we can support it in any way possible. Or if we have this. All right, great, better, much better. Okay. All right, so want to bring in the staircases. I'll going to start from the basement floor. And if you're like me, you know, modeling staircases can be very, very hectic. So there is the very good way to go about it. So what's this? Oh, okay, I see. I think we moved some of this out. These are not meant to show here. Okay, I see. Okay, let's edit this. Drag this out a bit. Use my dimension. In the process of trying to do something else, you always realize that, you know, there are things that you might not have, you know, completed already. Okay. Oh, pardon me, sorry, not this. This is not actually meant to be here. I just realized. So this here is meant to be the normal beam that is on this level here. So I'm just going to use MA, my match properties tool. And here, this is top of footing to ground floor. Top of footing. This here, top of footing as well. There we go. Okay, yeah, sorry. This, I remember this was just a bit excessive here. So why don't we just make this here 300, then take this back. Here's my floor. There we go. So let's make sure we support this. As well as possible. Okay. All right, so this seems much better. Let's move this by 600 outwards. And this little guy as well. Move it out by 600. All right. There we go. All right. So I'm back here on the basement floor plan. All right, great. So this is exactly what I wanted to be sure of. And so we have a sneaky little one as well. So one of the things about working with Revit, you can easily tell when something is off. Okay. All right. So I wanted to bring in the staircase. I haven't forgotten that. So, all right. So I want to bring in this staircase. So unlike slabs, walls, you can't copy monitor a staircase. But what you can do is that you can move towards it. I'll just press the tab key, select it. Then I'll press Ctrl C, shortcut on my keyboard. And then I'll just come here and then I'll go ahead and paste to the current view. Just going to accept this default here. It's much faster. So I'll do this here, Ctrl C, or copy here, align to current view. Very efficient way to bring in staircases without having to model it again from scratch. So great. So if I go to the 3D view here, you would be able to see that those staircases are now within the projects as needed. Okay, so let's come in the basement floor. I'll just come here and restore. You can see the staircases that we needed are here. Let's go over here to the ground floor plan. And I'll come here and turn on this coordination view. So we've already brought in this little guy here. We have this assembled staircase here. Select it, Ctrl C, come here, current view. There we go. Some railings came in as well. They won't be visible in any of our templates, I believe. So I want this. I want this as well. Some of those lead to steps that may be elusive to us. Then we have this one here. So I have 4 stairs in total. Ctrl C, align to current view. So if you're like me and you don't like modeling stairs, this is a very efficient way to bring them in. So just like that, we have all the stairs in the project they've been brought in. There we go, just like that. Good. Bring up my checklist. And we've done the staircase modeling. All right. Let me move this little guy out of the way. Okay, so let's go ahead and do the documentation. This is the most important part. If not, everything that we've done so far is pointless. So I come over here to my sheets, and for my documentation, the plans, I like to use the S100 series. So S101, my first plan. This should be the basement floor. So I would come here to views, then come here to basements, and then I'll click and drag this in and then place it. So here is the problem. So at a scale of 1 to 100 on an A3 sheet, it is almost illegible. I can barely see it here. So to squeeze everything in, I have to use a smaller scale. So let's try 1 to 200. 1 to 200 hits, and this works okay, I guess. Yeah, 1 to 200 is fine. If you cannot squeeze in everything, well, 1 to 200 is fine. But when you start to tag the elements, you may see why this may not be appropriate. So let's leave it as it is right now. Another option I would like to use is that I would like to change the sheet size. So this is an A3 sheet size. I think I have my A2 size here. Okay, I don't have my A2 loaded inside here. But I could. No, let's not do that. So you could opt for a bigger sheet size instead. Well, I'm just going to opt for the A3 size because A2 paper size A2 paper size might be hard to find. So I'm just going to opt for this, and I'm not going to have a viewport. I'll have it labeled inside here, the sheet. So this plan here, I'll name it to basement plan. There we go. All right, basement plan. Just want to make sure it falls within the sheet region. Move these elevations a bit. Make room for everything. All right. Okay, let's go ahead and create a new sheet. So I'll come here, right click. I'll come here and duplicate an empty sheet. And I'll call this sheet 102. I'll call this my ground floor plan. Locate the respective view. And as you can see, this also as well is quite big. So I'll change this here to 1 to 200. And I will create blown up views for them. Those blown up views will be where we can see the details better. Okay. All right, the ground floor plan. Here we have it. Can't see the elevations for some odd reason. Okay, so I need to restore this. Oh, okay, it was still in coordination view, so that's why. There we go. We have the ground floor plan. So we'll create blown up views. So we have 4 basic plans that we need. So right click, duplicate empty sheet. And first floor plan. More than the spelling, it should be first floor plan. All right. Let me open this view first. I'll have to turn off this, then change this here to 1 to 200. Yeah, and I can work with this. So drag this in here. Removes the hassle of me going to go and change this. Yeah, great. So come back to the sheet. We have one more basic plan. Duplicate this, duplicate an empty sheet. I'll call this S104, and that's going to be my roof plan. Okay, and actually we do have one sheet left, and that is the top of footing plan. That's the foundation for the ones that are going to the foundations actually. So we'd have to make accommodation for that. Okay, So that should come between the basement and the ground floor. So I'll right click on this, duplicate empty sheet, and I'll call this here 101A. I will renumber this later on. Then I will rename this here to, let's call this foundation plan. More specific to what foundation that is. Oops. So go to top of footing first. So we see this is using a structural layout plan. I'm going to change this here to my structural foundation layout plan. I have a special one for that. And here I have now removed the topo solids. It's been a culprit for a while now. From this template, there we go. All right, good. Okay, so we have 5 sheets in total now. All right. Just going to go ahead and save this. And now the idea here is that we can barely see this. We want to tag the element so we know what element is what. We can barely see this on this view. So I'm going to create blown up views to see the elements properly. And probably I'll use one as a sample here because that might take some time. I would admit to that. But I'll show you how we can actually do that, just like how it was done in the architectural. So here, I'm just going to come to start with the basement floor, the simpler view here. All right, click on this basement floor, I'll duplicate, and I'll duplicate with detailing. So I want it to be a separate view. Keep in mind this here. If you click on it, you can see this here, the view dependency is an independent view here. If I click on this one here, is also an independent view as well. But one of them is the primary view. And how do you know which one is the primary? If I go to any of the elevations and I, for instance, open up the basement floor plan, you can see it goes to this first one here. So this is the primary. So this here would be a secondary view. Blown. So I'll call this blown up. And once I've done that, I'll change this scale here to something bigger. Let's say 1 to 100. Or let's say 1 to 75 actually. All right, so 175. So I intend to place these 3 views on separate sheets. So before I place them, I want to create what we refer to as match lines. So to create a match line, I'll just come to the that is the view tab. Then click on match line. I'll create some sort of visual representation to show where I'm cutting through. So I want this to only be focusing on the basement floor. I'll give this a top offset of, let's say, 200. Alright, so this only affects the basement floor. I'll create 2 match lines here, showing there is a visual separation between these 2 elements. Then I will also create a match line here and a match line here. You may not really understand what is going on, but once we do that, once we place it on the views, it will make much more sense. So this blown up here, I'm going to right click on it, click on duplicate, and I'll click on duplicate as dependents. Now inside this dependents view here, you can see it's still taking 200. So I'll change this back here. You can see. Okay. So it's gone ahead and changed this original view back to, oops. Just want to, it's gone ahead and affected this. So I right click on this. And what I want to do is I want to make this one dependent here. So this is the main view here. we tend to make this blown up view a dependence view. So we have the setting here. Okay. I'm trying to see if I can do that. It's an independence view. Normally we have a setting here. To make it separate. Okay, this is what I'm trying to change. And two of them should be dependents here. It's taken this, should not take this. Okay, let's try something else here. It's all about getting the templates well. So come here, I'll duplicate this. Up. There we go. And views. Okay, all right, we're back. Do apologize for the break in transmission. Let's jump right into it. So we're in the documentation here. And we're in the process of creating blown up views. So I've gone ahead and created a new view type, blown up. And we will duplicate this here as a dependence. So whatever happens to this view here affects the views that are independent of, rather. The English didn't come out right. So I'm just going to make a crop region around this part here. Here we go. Just like this. So we just want to focus on just this slab. Okay. So you can see a match line indicating that there is something that comes after it. So I'll come here, duplicate, and I'll duplicate another dependence. So that's the blown up to show this region here. And I just want to make sure that it shows one match line here. So I created two. All right, and do crop. The Revit does a good job in trying to remove elements that are not needed when they are cropped out. So, and then come here, duplicate as dependent. Okay, so this one here, I'm going to turn off the crop view. And this one here should be for this area here. So all right, great. Let's save this. So how does this work? So we come back here. So we have our basement floor plan. So I'll right click, duplicate an empty sheet, and just for some sort of consistency, I'm going to call this one 101. Let's call this A. Okay, we already have 101A. So let's rename this to 101AA first. This foundation floor plan should come after it. So, let's call this 100. We will rename all of this properly. Okay, we have 100 already. Okay, this is general notes. So let's call this 002. One 101A. There we go. Okay, sorry. This should be 101 now. And this should be 100A. So much hassle just to change that. So we come here and I'll place the first dependent here. There we go. So every single view can have their own dependency. So I can have a title here showing exactly what this view is. Okay. Come back to the sheet and I'll right click, I'll duplicate, an empty sheet. I'll call this 100B. And I'll place my dependence view on this. Duplicate this. So these are all the blown up views. Great. So now that we have the blown up views, we want to make sure we can reference them properly, right? So if I come to this first blown up view here, this is dependence 1. So I just want to come inside here, double click inside the viewports, and I'll come here and click on view reference. So inside this view reference here, I want to reference dependence 2. So that's the one that comes below it. So I click here and place that. There we go. Great. So this will also help as well when we're looking through the other views. So dependence 2, if I come inside here, I'll come here, place this view reference. I want to look up. So that was the first view. That's dependence 1. Then just below here, I want to look at dependence 3, which is on 101C, which is the sheet we are going to now. So I come back here, not match line, view reference, and I want to look at the one in B. Oops, didn't see it. So the reason for that is because of the annotation crop. All right, great. All right, good. So here, I can just change this here to title only. Let's put title on scale. All right, you can see it shows the detail number and the sheets they are on as well. So this one, if I select this viewport here, I'll change the detail number to A. I'll come to this next sheet here and I'll change the detail number to B. And then this sheet here, I'll change the detail number here to C. So it's much easier for me to understand what's going on. So you can see that's B on 101B. This one is A on 101, 100A rather. And then this is C on 100C. So cross-referencing made much easier. All right, let's look at how we can go ahead and annotate. So let's start with this basement plan here. These are the blown up views. So this is what we want to dimension. So I'm just going to pull up my dimension too. And I want to dimension within the supports first. Then I would go ahead and now take a full dimension at the top. So this is how ideally I would dimension my elements, or rather, yeah, elements as it stands. Okay. So we have this here in between the supports. So this one here, add the dimension. I want to make sure you can reference every single element. Any small dimension missed, they would have to pay for it during the construction. Here on this side, then here on this side. All right, great. So I'll turn off the crop region visible so we can see our dimension better. In fact, just looking at it, because they're already called out, I can just rename this as basement plan blown up. These 3 views, I'll name them blown up. And remove the title. So because this dependence might be a bit hard to understand what is going on. So with the view reference, it's much easier to understand what you're looking at. Okay, great. That was actually quite faster than I expected. Okay. All right, so we've done that here. For this view, let's go ahead and dimension the other views. So let's turn off the crop region visible. Let's do the dimension here. Okay. I also want to put a dimension here showing the width of that staircase. So dimension here showing this width here. There we go. All right, let's add these dimensions here. There we go. All right, great. So dimension all the three views here and they can be cross-referenced. So we have the basement floor plan here, which should be at 200. While the other ones are at 75. So here we can see everything here. And then if we want to go to the blown up views, we access them from the sheet, just like this. So the same thing would be replicated for the foundation plan as well. So probably I'll do a match line that looks at this region, that looks at probably this region as well, this region, this region, this region. So make it much easier. So now for the basement floor plan, I would come here to the main view that is here, and I will quickly tag all the elements so we know exactly what we're looking at. And I already have the tags in this template, so I'll click on annotate, tag all, and I'm looking for my wall tags here. So I'll click on apply to quickly add the tags. You can see in the background they've been added. Great. So I have all my wall tags placed automatically for me. They've not been numbered because we haven't designed them yet, so we don't really need to focus too much on that. The most important thing is that we can see the sizing of the walls. We want to adjust some that were not placed properly, so we can see the ones that are different. Here, yeah, might as well just have this one come out a bit. Why not? Okay. So the only typical elements we have on the basement floor are just the walls and the slab. Okay, now because we've done this in the major view, if we come to any of the dependent views, we can see they've also been applied as well. So you don't have to go and do them in sheet by sheet. So Now that we've done that, let's go back to the blown up view. And what we're going to do here is that we're going to go ahead and place a detail showing that this is a slab. So I'm going to come here to my detail group. I'm just going to pull up this subway symbol, indicates that that is a slab. All right, good. And what I want to do is I want to put a text note here showing the thickness of the slab. Normally I would use tags, but in this case, I don't really want to because it would take a lot of time because they are singular panels. Let's come to the annotate tab. I also want to show the elevation that they are at. So spot elevation. If you want to use the spot elevation project. Plan projects here. There we go. I always keep changing this. I like to maintain a particular aesthetic. And let's see. Let's just leave it as it is. Okay, great. Yeah, I like to show what elevation the slab is at different points. And then I'll put a text note showing the thickness of the slab. So the, let's say it's equal to 250 mm. There we go. I think there should be a plan relative, not this. All right, let's work with this. Okay. All right, so you see that everything as well would be reflected on the plan views. Now let's go ahead and do that for the views that unfortunately we won't have enough time to place them on sheets, but I'll show you us how we can do that. So here we're going to adopt the ground floor plan rather. We're going to go ahead and adopt 175 here. There we go. And let's quickly tag all the columns and the beams. So just imagine having to do this manually. Come to tag all, and if you have a very good tagging option or tagging family for the beams, columns, it makes it so much faster to work with. All right, so we have the ground floor. The majority of them are framings and walls. So I click on apply, boom, and that has been automatically done. So this particular column here, I need to go ahead and change the name. And this is a 600 by 15 column. Okay, it's been changed actually, 600 by 15 mm. Okay, so if I click on the tag, I click on select host. I click on the tag and I click on select host here. So you can see that's the right host. You see all the other tags as well have been placed. Okay. Seems like we're missing an element here. Okay, I'll use the switch join order. So it wasn't visible before, but now we can see it. It's just like that we've tagged all the elements on the ground floor. Do the same thing as well for the first floor. Change this here to a custom scale of 1 to 75. And I'm going to come here, tag all, structural columns, walls here, and framing. There we go. Great. So you can see that I placed the column tags, but they are all showing question marks, and that's because these are the ones that show marks. So I'll type SV to select all the tags in this view. So we have about 54 visible columns here. What I'll do is I'll change all the types to type only. So at this point, we don't want to give them names. We just want to show the names of the columns. I mean, the type of the column, what size they are. Then for the beams here, I don't believe I turned on structural framing tags. Great, there we have it in place. Okay, let me just switch this so we can see this better. Here we go. All right, let's do the same thing for the roof floor. The roof floor, because most of these columns are terminating, may not need to actually tag them again. So I'm just going to tag only the framings, the beams. Great. So I actually need to change the scale first. Okay, before I tag. So let's go with structural framing. There we go. All right, good. And here, also we have a roof slab over here. We actually forgot how to model that in place. So we're going to structure. And we'll place the roof slab in there. There we go. So I'm going to switch to join order so we can see the beams over the slab, just like that. All right, great. So we're done with the general arrangements and we're just going to populate the views. So we have just the basic basement floor plans, at least we can do for the time being. We have the compressed views for the foundation plan, the ground floor plan. So you see for some odd reason. Okay, yeah, so we can't do it because we haven't created the blown up views for this actually. The foundation plan as well, this also needs to be worked on. Well, maybe another time actually. Let's just remove these ones here. We want to place the blown up views on them later on. All right, great. Now, in my S200 series, I like to put the elevation. So we have here front and back view. Just going to close this. So I'll just come to my views and just go and place here. This should be front and back view. So I'll take both south and north. So I'll come here, drag the south in. And yeah, the scale is quite big. So let's opt for a custom scale, something smaller. Let's say 200. 200 seems fine. I'll change this here to title and scale. There we go. Then I would drag this extent back a bit. Okay. Then I also want to do the same thing as well for my knots. First of all, I'll change this here to this. What did I use for this? So I use 200. So I use 200 for this as well. So I changed it before bringing it into the view. All right, and then just place it so it matches. And then we have the nuts. So there's this technique I normally use to make the elevations cleaner. I also do this for plan views as well, especially when we have lots of reinforcement. So I come here and crop some parts of the elevation line, and then this changes to a 2D extent. So I just drag this all the way back. There we go. So I can now turn off the crop region visible. Then I would, okay, you know what, let's come here. Drag this down. Drag this up a bit. Then I would do the same thing here. Turn up the crop region visible. And just extend this back. Just have a much more cleaner view. Elevations are very nice in your structural drawings because you can see how the elements are at different levels. It's a much more cleaner look actually as well. So let me check this one out a bit. There we go. All right. So the same also could be done for the side views, but because of time, we may not be able to cover that, unfortunately. All right, so let's look at the 300 series, which covers our schedule. So this is beautiful. It's already been populated for us. So we have an idea of the whole concrete column schedules. It shows us the breakdown as well and the total volume. So most of the times, this is what the clients are actually very interested in before going to proceed with the project. So we also have a 3D view as well, just to see the project. So this is the concrete slab, concrete beams, concrete columns. We have another sheet, I believe, as well to show the structural walls. So just going to go ahead and open up this. There is a filter here that enables us to see what we want. So here, I'll go to let it to see none, so I can see every single type. And here, for the type varies. So I'm going to come back here, click on sorting and grouping, and then sort by the type, so we can see every single type out there. There we go. We don't have any power caps, so I can remove the schedule. We don't have any powers. Remove this. And we have foundation beams actually. So these foundation beams are meant to be the 225 and 300 by 21. So what I'll do is I'll just go to this schedule here. I'll call this concrete structural wall and foundation beam quantity schedule. There we go. Because they fall under the same category. Alright, so I might as well just move it to this sheet here, 301, since we have some space. So I'll right click on this, click on move align to space, 301, and then I'll move it to that sheet. So I just drag it above here. That's our 300 series. Alright, great. Okay, so we've been able to come up with some sheets here, and ideally you would want to populate it for the remaining, as well. So that's the foundation plan, the ground floor plan, the first floor, the roof plan as well. So create all the blown off views, and all those blown off views as well must show their respective details. So the columns must show the tags showing the type, the floors must show the thicknesses, all those details, they need to be there. The walls must show their tags, the beams must show their tags as well. Okay. All right. So once that's been done, we can now go ahead and export. Before exporting, we need to make sure that we populate our sheets with all the details needed. So yeah, if it was drawn by you, you want to put your name. So I just click inside my title block and I'm just going to put my initials say AA, right? And if it was designed by me, I put AA there as well. All right. Now the problem here is that if it is for one sheet, it doesn't reflect on all. So I can click on one of the sheets, type SA. So I have a total of 16 of them in total. Then inside the properties, I can change everything at once. So this is good because you may have sheets that are designed by different people or drawn by different people here. So designed by, checked by, that's fine. I don't have a project name. This is just a sample project. But if you do have a project name, you want to change or put the project name, you put your client's name here as well. The advantage of this is that if you put it here, let's say I put AA here, project name, A. Let's say project name, I call this residential developments. All right, so this particular two data here, these are project information data, so they reflect on every single sheet. All right, and if we come to the manage tab, under projects, properties, project information, this is actually where you can populate the information. So we can see here, we can put in our project number, all other details that are needed here as well. Whatever I put here would now be reflected into the title block. Okay, great. So now we have all the sheets. We don't have anything in our S500 or S600 series. We just want to export the basement floor plans here. And we want to export this S101A view as well. Likewise as well, there is also it's good to also have your, sheets list or your drawing register here. So it shows the list of sheets that you want to show. So I'll come here and you can see our blown up plans. We don't want the foundation plan all the way to the roof plan to show. So I'll come here, select this particular sheet, then I'll turn off this appear in sheets list. So it's exclusive from the sheets list. And my side view, I have not populated that, so I'll remove that. Yeah. And let's see, we have 3D views which are in this view here. So S302 to this, exclude those as well. And we have S500 here. We don't need this, so we're just going to export a measly one to, okay, general notes as well. We're not actually going to show this as of the moment. All right. So we have measly 1, 2, 3, 4, 5, 6 sheets in total. And that also covers our cover page. So although we don't allow our cover page and our sheet list to be inside the sheet list, it's like having table of contents labeled in table of contents. So I have my cover page here, which shows the full structure. It's quite nice. I have the sheet list here, showing the current list of sheets that I intend to export. I have my basement floor plan. Then I have the blown ups. They are showing the match lines and the view references. Then I have the front and back view. Okay. All right, so let's go ahead and export this view. So, and ideally as well, also for the elevation, you also want to kind of do a dimension. So between the levels like this. Yeah, there we go. You want to show dimensions between the levels. And likewise as well, you want to dimension between the grid lines. The respective grid lines. You put a dimension here, then you add another dimension here as well. Another very nice detail I like to add is to show the elevations at different points. So if I come to Analytics tab, I have this option here for spot elevation. So I'm going to go ahead and use this spot elevation here. I don't want any leader. So it shows the elevation at different levels here. It can be a very nice feature because not every single element may fall on the level. You may have some sort of offset distance. So you can see this particular floor is at 1000. This is at 600. So you can place them on your elevations and your sections. So you can see where we have the wrap foundation here. There we go. It's a bit too close, so I can just remove this. All right. Okay. Also replicate that for this view, but I'll assume that's been done. So if I want to export, I just have to go over here and click on the PDF tool. I can also access from file. I want to export multiple sheets, so I'm going to come here and I'll click on this pen icon here, and I want to create a new sheet set. So let's call this planning. All right, and I'm going to uncheck all of this. I don't want all this, so uncheck. I want the option to actually choose the sheets I want, so I'll go ahead and filter it out. So I want the cover page, I want the sheet list, then I want the basement plan all the way to the blown up plans here. We haven't populated these sheets, so I'll pick this front and back view and the general concrete and quantity schedules. So once I've selected the ones I want, I just save the current sets. So everything now falls under this planning sheet, and I click on select. That's a total of 8 sheets. And then I'll pick a drawing setup of my choice, and I choose the location where I want to export it to. So if I click on browse, I will just accept this to go to my downloads folder where I have the project saved. So I'll right click, I click on new, I click on documentation. So I like to put all my PDFs and related documents inside the documentation folder. There we go. So we can see the name is automatically the same name as the project itself. I'm using a A3 size, which is the same size as my title block, to match all the settings as well. All right, so if I just go ahead and click on exports, it's going to export my drawings, and very shortly we would be able to see it. So I'm going to go ahead and open up the structural folder. We can see our documentation. So it's still in the process of exporting. You can see the progress over here at the left corner. So wait a while, and so it's export. So you can look at it in the PDF. All right, it's been a very long day. I do hope everybody has been enjoying the stream. Likewise as well, let us know where you're joining from, and we'll be glad to give you a shout out. Okay. All right, so you can see here the export is done, and it gives us a little bit of warning. So elements that have some sort of shadows, it uses a particular technique to export them. That's fine. So I'm just going to come here, and we have our PDF here. I'm just going to go ahead and double click to open it up. Great. And we have our documentation here. All right, so this is our cover page here. If I come to the sheets list, I have a total of the sheets that are here. And we have the basement plan. So you can see the only elevation that was placed here is the one that can be referenced. So this is on S21A. And likewise, also this is on S21A. So this is detail 1 and this is detail 2. So if I click here, it takes me to that particular sheet. Okay. So this here. Okay. Great. Sorry. Let's go ahead and open that up again. So we have the basement plan. We have the basement plan blown up. And the good thing about the view references is that instead of going to the next page, if I click on this, it automatically takes me to the reference. If I want to go back here, it takes me back here. I can also look at the thumbnail to see what I'm looking at. So it's the third page. Goes to the one just below. So this particular portion here is this part here. And this part here is this particular point here. So how we use the match line, we can easily see what we are looking at. Here we have the elevations. And for the elevations, we only have, I believe, the basement floor. So that's why that is the only one that can be referenced. And here we've been able to provide the basic deliverable needed. Well, we were not able to actually place all the layouts on the views, but we're able to show that, okay, this is how much that is going to be going into the project in terms of materials. So the schedules are the most important things. When we're planning, we want to see the arrangement of the columns, the beams, the walls, the foundations, elements, everything all together. We'll look at the total mass and from here, any clients will be able to make a decision with their QS and see what the way forward is. All right. Okay. Once again, I really appreciate everybody for joining the stream. I look forward to having more sessions like this, probably in the future. Hope you did have a great time, and we would see each other soon. All right. The recording will be made available as well as resources to learn. We have courses as well that could help you, fast track your progress in professional development, structural design, architectural design, coordination. Feel free to reach out to our WhatsApp community. We're always glad to provide resources, free resources for you. And also, we're here to guide you. We have guided mentorship sessions as well on the area that you want to further in your career. We're always free to, guide on that. Okay, catch you in the next stream, and look forward to seeing you guys.